Welcome everybody to this brand new ethical hacking course. Now, as you can see right here, what this course will cover is coding botnet backdoor in Python for ethical hacking. Now, this course is posted on Udemy about 1 week ago, and what you're getting right now is half of the course on YouTube for free. If we go down here and see what this course covers, you will see it has 3 sections. First one is coding advanced undetectable backdoor. The second one is implementing Keylogger to our backdoor, and the third one is making a botnet server which you can then use to launch your own DDoS attacks or any other commands you want on multiple targets. If we go up here, we can see what you'll learn: creating a botnet, advanced backdoor in Python, code an advanced keylogger and implemented it backdoor, learning Python for ethical hacking, maintaining access on your target systems with persistence, creating undetectable backdoors, capturing screenshots on target system, ethical hacking, learn how to command multiple targets simultaneously, code custom pen testing tools. We will be coding all of this in Kali Linux, check for escalated privileges, backdoor any file type such as pictures, PDFs, and so on, backdoor that reproduces and that can actually be run at startup every time a target turns on their PC, and all this represents penetration testing. So, in this video right here, you will get the first section for free, which is coding advanced undetectable backdoor. And if you simply just like the course and you want to see how you can implement the keylogger to your own backdoor and how you can create a botnet server which will be able to execute commands on multiple targets at the same time, as well as command multiple sessions and switch between different sessions or different targets at the same time, then you can go to this page right here and simply just use the code hacking for the maximum discount on this course. As we can see, 95% off, and you can get this course for $9.99 with the code hacking. So I hope you will enjoy it, and I hope I will see you in the rest of the course on Udemy. Take care. Bye. Hello everybody, and welcome to the multifunctioning reverse shell section. Now what we are going to do in this section is basically coding our own reverse shell, which will be based on the TCP server and TCP client. So we will actually code 2 programs. One of them will be our server, where we will listen for the incoming connection, and the other one will be the reverse shell, or the payload, or however you want to call it, which we will deliver to the target in order to hope that they will actually run the program and connect their PC back to us, which will then allow us to execute multiple functions that we will also code, such as screenshotting target's PC, running keyloggers, getting administrator privileges, opening files, downloading files, uploading files, downloading other scripts from the internet, and so on and so on. So it will all be based on this part right here, which is the code that we need to make in order to be able to connect one PC to another. Now, those of you who are coming from my ethical hacking course have already some idea what we are going to code. It will most likely be all the same. We will change some of the different things at the end, such as actually making our reverse shell to be a song, for example, an MP3 file, which will run a song in the background, or an image, or the PDF file. We will also see how we can add multiple different icons to our file. And those of you that are coming from the ethical hacking course know that we didn't really code the reverse shell to be able to, or not the reverse shell, the server to be able to accept multiple connections. So that is something that we will do in this course. So we will code the reverse shell, or pardon me, the server to be able to accept the connections from different PCs at the same time. So you can actually connect multiple targets in order to execute commands on all of them. We will be able to switch from the first session, for example, to the second session, and so on. It will be something similar to the meterpreter shell and the exploit multi-handler. We will just try to copy all of that, as well as some of the functions, and then we will see how it will all go. That is the base of the actual command and control center, which will be able to create the botnet for your own needs. Now, most likely botnets are always used for DDoS attacks, which you really shouldn't do without permission, but you will be able to create something like that. Nothing really too advanced, since this is also a course for beginners, but I assure you it will have some of the different things and some of the more advanced things that the reverse shell should have. So let us see what we need to code in order to get this to work. This will be the basic principle behind all of this, which will contain the server and the client. The client in our case is our reverse shell, and the server is a program that we're going to run on our Kali Linux machine. So as we can see, we will need to create the socket object, which we did before, so nothing really new for us. We know what socket object is. We used socket library before, so all we have to do is create the socket object and bind certain IP address from our Kali Linux machine to the port that we want to listen on. In our case, we can use any port we like. We can use port, for example, 54321 if you want to. You will basically use any port you want, which is not in use on your system. What we need to do afterwards is listen for the incoming connections, and then after we listen for the incoming connections, the target can actually connect back to us. What the target will run is in the target code we will also make the socket object, and then we will perform the connect function from the socket library in order to connect to the IP address and the port that we specify in the server code to listen on. Then our server code will, as it says right here, establish connection with the three-way handshake over TCP, and it will accept the connection, and then we will be able to send the data or messages or commands or however you want to call it back and forth between our PC and the target PC. So afterwards, with the receive and send function, what we are going to do is send different commands such as, for example, ls or dir in order to print the files in the working directory, change directory, upload files, download files, and so on and so on. And at the end, when we don't really want to connect back to that target, we can just press a certain command such as exit or just type exit or something like that, which we will code in our program to be equal to actually closing the socket or closing the connection, and that will terminate our session with the target PC. So all of this we will be actually coding, so this will be a longer section, so prepare everything you need. This is one of the more useful things you will actually need, since this is the actual Python program that we will convert to the exe, and it will be able to run on any Windows PC. So you can make any Windows PC your target as soon as you find a method to deliver this to the target. And we will see also the method as well. We will see how we can send fake emails, how you can also deliver this if you want to over USB drive. So if you're physically close to the target, you can just take your reverse shell exe file and then plug it into the target PC and run it when nobody is watching. Now, the actual bypassing of antiviruses will be, this program will actually be able to bypass most of the antiviruses, but not all of them. We will try to make sure to add some functions that will do literally nothing, just to be able to bypass some of the antiviruses. Such, for example, if you add a function that just does normal things such as adding numbers, extracting numbers, and so on, it might trick some antiviruses into thinking that this actually isn't any virus at all. So we will be taking a look at all of that in the next video. What we will also need to install, which we will start actually with, is the Wine installation. Now, the Wine installation allows us to actually be able to convert the Python file on our Kali Linux machine into the exe file, which will allow us to run that code in the Windows PC environment without the Python interpreter. So that is something really useful. We will use the PyInstaller library from it, and we will compile it into one single file. And the reason why we will not be able to bypass all of the antiviruses is basically because of the PyInstaller, since PyInstaller library for Python by default gets actually detected by some antiviruses as an actual virus. So even if you coded a simple program which just prints hello world and converted it to exe with PyInstaller, it will still trigger some of the antiviruses out there. So that is something that we cannot really change, but we will be doing the most we can in order to bypass most of them. So hope you enjoyed this tutorial, and I hope I see you in the next one, where we will start installing our Wine installer and we will start coding our program. So hope you enjoyed it, and I hope I see you in the next tutorial. Bye! Hello everybody, and welcome back to this tutorial. And right now what we are going to do is we are going to install our Wine in order to be able to compile our reverse shell later on. So all you have to do is run just a few commands, which might actually take some time in order to install, but after you do that, you can safely compile all of your programs that you want to run on your Windows environment as an exe file. So let us zoom our terminal in so you can see every command good enough. And let us run our first command, which would be the dpkg and then dash add dash architecture. So just type this, and after you type this, you just want to type i386. Now basically we are running this command in order to add our architecture for our 32-bit wine, which are going to install soon enough. And basically I already did all of this process, or the entire process, so I will not be actually running the commands right now. I will just show you which commands you need to run. The reason behind this is because the apt-get install wine32 takes a little bit of time, so I ran it before, so we don't have to wait through this video in order for that to finish. The next command, what you want to do is just apt-get update your repositories in order to be able to download the newest version of wine32. So just update your repositories. This shouldn't take too long since I didn't really add any additional repository to my sources.list file in Kali Linux. And after that, all you want to do is just install wine32. Now, what wine32 allows us to do is actually run Windows programs in Linux. What it will do, it will create a virtual C drive, the same C drive that you use on Windows, and it will allow us with a certain command to actually be able to run all the .exe files in Windows environment. So, the reason why this is failing is because I'm not really connected to the internet at the moment. For you, it should work. And right after that, you want to type apt-get install and then wine32. What this will do, it will install the wine32 for you. It might take a little bit of time, around 10 to 15 minutes, in order to install all the files you need for this. And after you do that, all you want to do is actually navigate to our root directory. And there, if you type ls, you will not notice anything different. But if you type ls-la right after installing wine, you will see a folder or a hidden directory which is named .wine. Now, this directory is basically where your C drive will be. So if you change your directory to .wine and type ls once again, you can see our drive C right here. Change directory to drive C as well. And there you will have these program files x86, the usual files that you see in your C drive on Windows. But what we want to do right now is install this Python 27. So what you won't have is this Python 27, and right now I will show you how you can install it. So just close down your terminal and open up your Firefox. We will download a Python 2 version, which we will use then to compile our programs with the PyInstaller library. So let me enlarge this and just type the link, or the same link that I'm typing, so www.python.org/ and then downloads/release. And now we want to specify which release we actually want, and we want the release Python-2714, and then add a slash at the end, and you will get redirected to this page right here. Now here, as you can see under the Python 2.7.14, we have different versions available, and the one that we are interested in is the Windows x86 MSA installer. So just click on that. This will start the process of downloading it for you. It will first prompt you to save the file, so click save. Then under this icon right here, you will see that the file will be downloaded in the downloads folder on our Kali Linux machine. So after you do that, we can actually close the Firefox right now and go back to our terminal. And if I navigate to my downloads folder, which is under /roots/downloads, there, if you type ls, you should have a file named something like this. Now the reason why I have two files is because, as I said, I already downloaded it before, so I will just delete one. No such file or directory. Okay. Let me try to delete the one that I downloaded before so you don't get confused. Basically what you will have is the other one. Okay, never mind. We will just delete the new downloaded one. So you will have file named something like this. And what you want to do is run a command which goes like this. So wine and then msi execute or just iexec, and then after that /i, and then the name of your download. What this will do, so you just specify enter, it will actually run the Python for Windows in your Kali Linux environment. It will prompt you to install, so you just go next on every actual step you have in the Python 2.7.14 setup, and after that just click finish and you will have Python installed. So I will just cancel this since I actually don't want to install it twice. And that would be about it. Right after you install the actual Python, you can see that you will have Python under the root /wine or /.wine under drive C. If you type ls, you will have Python 27 right here. But we don't only want Python, we actually want a certain library that comes in Python, which will allow us to compile our Python programs in Linux into .exe files. So in order to do that, what you need to type is this command. The name of the library that we're going to install is pyinstaller, so here I will show you how you can do this. So wine, and then you need to specify the path to the python.exe. And the python.exe file or program that we just downloaded is located in Python 27 directory. So you need to specify the full directory, so root /.wine /drive C /python 27 and then /python.exe. This is the full path to your Python exe program, and then after that you need to specify -m to install the library and then pip install, and then the name of the library itself, which in our case is pyinstaller, and then just press enter right here. Now this is the actual same command that you will use to actually install any additional library that you might need, since sometimes in compiling of the program you will get a fail to execute error. The reason behind that is usually because you're missing a certain library in your Python exe program. So that will be about it for this tutorial. We successfully installed Python for Windows and we successfully installed pyinstaller in our Kali Linux environment. So hope you enjoyed this tutorial, and we will continue with coding our server in the next lecture. Hope I see you there, and take care. Bye. Hello everybody, and welcome back to this tutorial. And this is the first tutorial where we'll actually start to code our reverse shell and our server that will accept all of the connections to our Kali Linux machine. So first of all, let us start off with the server, since the socket code for the server is a little bit bigger and more complicated than the actual socket code for the reverse shell. In server there are multiple functions that we need to execute in order to perform the entire connection, while in the reverse shell we will only need to perform the connect function after creating the socket object. So let us navigate to our Python programs, so root Python programs. We can call this mkdir, we can call it reverse_shell. That will be the name of our actual directory where we will save our reverse shell and server and any additional actual programs that we need for this section. So let us first of all nano server.py, just a simple name, we don't need anything to specify else. So just right here add the additional line user bin python, and we know that we are going to use the socket library as the first library in order to create the connection. So first of all, let us just try to create the connecting of these two programs from two different machines. Now for those of you who are coming from my previous ethical hacking course already know how we are going to do this. So if you already watched this in my ethical hacking course, feel free to skip to the end of this section, where we will actually change some different things and compile the program in a different way in order to see what our available options are for running this attack. But for those of you that are watching this for the first time, let us continue. So what we want to do first is to create the socket object. So we will store it in a variable that we will call simply just s. In order to create socket object we are already familiar with, we need to run the socket.socket function, and in these brackets right here we need to specify what type of socket object we want to create. So we will paste two arguments right here. One of them is socket.af_inet, which will allow us to create a socket object for the IPv4 address, since we are going to perform the connection function onto the IPv4 address on a certain port. Also, we want to specify whether we want our server to be running over UDP or TCP. We want to actually run a full TCP three-way handshake connection with the TCP protocol. So in order to specify that, we need to just type socket.sock_stream, and we successfully created our socket object. So once again, this stands for IPv4 connection and this stands for TCP connection. So in the next line, we will set some of the options for our socket object. In order to do that, we will use a function called setSockAuth, and in the actual brackets, just specify socket.sol_socket, comma, socket.so_reuse addr. After that, comma 1, and that is all we need to do for our socket object in the entire program. We set some of the options, we also created the socket, and right now we are going to run our next function, which is actually the function that we saw in the previous theory video, where we actually explained what we need to run in order to perform the connection, and that function is actually called bind. So if you just type s.bind, what this function does, what this function does is it will bind your IP address, your local IP address, to the actual port that you specify in between these brackets. So what you need to specify right here is the IP address of your Kali Linux machine, and also to specify the port that you want to bind to that IP address. Now make sure before you specify anything that you make sure that that port is not used by anything else, otherwise this won't work. That's why I always like to use some high port, for example 54321, because I know that most likely non-programs will be running on that port. Also, the bind function takes the arguments between the double open and close brackets, so make sure to specify double open and double close brackets, and in between there, first of all, you specify between the double quotes the IP address. So in order to specify our IP address, we first of all need to check it, run ifconfig, we can copy our local IP address, nano back to our server, and paste it between the double quotes. Right after that, we need to separate comma and add the port that we want to bind to, in my case 54321. So after that, we need to listen for the incoming connection. So now that we created the socket object and that we binded our port to our IP address, we need to listen for the incoming connections. In order to do that, we need to specify the listen function, and in between to how many connections we want to listen for. For example, specify 5. You can even use 1 for this actual test, but 5 will do the same job as well. After that, we can actually print a few statements which will allow us to know whether we completed these statements right here correctly, or whether we ran into some error. So let us print the successful execution in in green, and the failed attempts in red. So from term color, import colored. So what we are going to do is right here we can print colored, and then let me just, okay, so we need to specify plus, since this means that it worked, listening for incoming connections. So make sure to close two brackets, and then after that, since we know that we are now listening for the connections, we need to specify two variables where we will store the actual connection. So one of them will be the target, and one of them will be the IP address, which we will use as a string in a later program. So what this means, the socket object we are going to store in the target, which will store it somewhere in the memory, and the IP address or the IP variable will store the IP address and the port from where the connection is coming from, which then we will use this IP variable in order to print from where we got the connection. So we can just type here s.accept, since we are accepting to our socket object, and we can see print, and we can print colored connection established from, and then we can use %s since we are going to specify a string, and we can just close the double quotes and here use %string from IP. Make sure to close 1, 2, 3, and or just 3 actual brackets. So I hope, let me just count. So we got 1, 2, 3 open and 3 closed. Okay, so everything is good enough. And basically this is the entire program for actually creating the server side of the connection. So what we're going to do in the next video is we are going to code the reverse shell part, which will only consist of the connect function, and then we will test if our program can actually connect to our server. So let us just save this, and we will continue in the next lecture with our reverse shell. So hope you enjoyed this tutorial, and I hope I see you in the next lecture. Bye! Hello everybody, and welcome back to this tutorial. And right now what we are going to do, we are going to call the reverse shell side of the code. So we can see right here, we successfully coded the server side, and right now let us exit this and nano reverse shell.py. So we will call it nano reverse underscore shell.py. We add the standard user bin Python line, and we will import the socket library as we are going to need it to actually specify our socket object. So we can call it socket or just sock, so we don't actually confuse it with the socket library. So all we want to do right now is specify the same thing as in the previous video. So sock equals socket.socket. We want to use the socket.af underscore inet, and we want to use the socket.sock underscore stream, or I believe it is stream. Let me just double check. I will just cat my server in order to see. Okay, so it is sock stream. Okay, so we specify the socket object, and what we want to do right now is perform the connect function. So in order to do that, we can just type sock.connect and open double quote, double brackets, double open and double close brackets, same as in the bind function in our server side code. And between there you need to specify the IP address to which you want to connect to and the port to which you want to connect to. Now in our case both of them will be the same, so we need to specify right here once again between the double quotes the IP address of our Kali Linux, which is in my case 192.168.1.9, and also the same port that we used in the server-side code, so 54321. But be careful, if you are running this attack over the internet, for example, and you use the port forward, what you want to specify in the reverse shell code is actually your public IP address that actually your router has in order to communicate with the internet. Of course, you also need to specify the port forward in your router settings that will actually forward this local IP address to a certain port over the router. But from now on, since we are doing just a local tag at the moment, we can just leave it like this. So what we want to do is just save this and see if we can actually perform the connect function. But before we do that, we need to close the socket in both of our programs, which we can do with just sock.close function. So just write that, exit this program, let us nano our server, write right here as well sock.close, save this as well, and we know that this program will work if we get printed this line right here. So we want to get printed connection established from certain IP address at certain port. So let us save this, close this, and in order to run both of these programs we will need to open two terminals. So just open another terminal. We can enlarge both of them just for better view, even though we don't really need it at the moment, but let's have it just so you can see everything better. And right here, what I want to do is navigate to the same directory, so reverse underscore shell. And first we need to run the actual server. So let us chmod server in order to make it executable, and let's run server code. No module named term color. So okay, we need to run it with Python 3 since I use the term color library, and we can see listening for incoming connections. Now we can see right at the moment that we have something that isn't specified correctly, so we know that we specified the colors, but we forgot to actually add the color which we want to use. So in order to do that, we need to specify the comma after the string and then the name of the color, so we want to print it in green. Same right here. We want to print this in green, and let us save and try to run once again. So Python 3 server.py, address already in use. That is because we actually closed the program 2 seconds ago in the inappropriate way. So let us actually restart our terminal in order to get this to work. Now remember, every time you get server already in use, all you have to do is actually just restart your terminal, and it should all work fine right after that. So let me just go to my Python reverse shell and Python 3 my server. Name green is not defined. Okay. Yeah, green needs to be specified between the single quotes, so make sure to add that as well. And right now I believe everything should work good. Okay, so listening for incoming connections, and right now this will listen until somebody connects to our program. In order to perform the connection, we need to run Python 3 reverse shell.py. So we run this, it says connection established from 192.168 at this certain port. So this was the port that was used to perform the connection from the reverse shell. Now we have a small error right here since we used sock.close instead of s.close in our server. So let us just run it once again, and let's run this, and we can see everything executed properly. We got listening for incoming connections, we also got connection established from this IP address, and we closed both of these programs in the appropriate way. So what we want to do in the next video is actually try to send some of the commands or some of the messages between these two programs. For now on, we only made them connect to each other, but we also actually want to be able to send something between them, since these are the programs that will be running on two different machines. Just at the moment, we are testing them in the same machine, just from two different terminals. So we will continue coding in the next lecture. Hope you enjoyed this one, and I hope I see you in the next tutorial. Bye! Hello everybody, and welcome back to this tutorial. And as you can see in the previous video, we successfully ran both our server and our reverse shell.py. Right now what we are going to do is add just a little bit of code to our server and to our reverse shell in order to be able to execute or to send messages between these two programs. So let us start off with the server. I will just zoom this in so you can see everything better. Let me just enlarge the entire terminal and let me open server.py. So what we have here is the actual socket creation part. So what we can do with this is, first of all, delete the s.close and put this entire part into one big function, or it is not even that big, but we can just add it right there. So what we can do is just type here def server, and we can tab this entire code into this function right here. So we tab everything right here as it should be. And also what we need to do right now is actually create a global variable s, since we are going to use the s in other functions as well. And we actually must have the s variable to be global in order to be able in order for our program to be able to recognize the s variable. So we can do that just by specifying the actual, let me just go right here. In the beginning of the function, we can just specify 3 global variables. Since we are going to use the global variable s for our socket object, we are going to use the global variable IP, since we are going to print it later on. And we are also going to use the global variable target once we actually specify functions which we will use to actually send and receive data between these two programs. So all we have to do down here is actually call this function server, so we can actually execute this part of code. And right after that, we're going to call the function called shell. So what this function shell will do is it will be a function that will perform the actual sending and receiving of the messages. So let us go up here, type def shell. The function will not take any input right now. And what we want to do is basically at the beginning of the function, we want to enter an infinite while loop. So we can do that with while true. Now the reason why we are entering the infinite while loop is because we want to send the commands for as long as we want. But before we actually enter it, let us just try to test the program in order to see if we can actually send messages without the while true loop. So what we can do is just type here a variable called command, which will be our command, or basically we will store the command that we input into this program right here. So what we want to use then is the actual so command equals input. We want to ask for the input of the user, or in this case us, and we want to add something like this. So shell that just paste everything that I type right here, so hash. Then we can use this sign and then %s, so %s and 2 dots in order to make this look like a terminal shell. So you will see how this will look like. If we just add instead of the %s, we will add a string of the IP. So because of this usage right here of the IP variable, we had to specify it in the server function to be a global variable. So we close the double brackets, and all we want to do is actually just try to send this to the target. So we can just use s.send, and what we want to send is actual command. And after we send this, so right now what we want to do is actually receive some message from the actual target. So we can just do something like this, message equals target.receive. And the amount of bytes we want to receive would be 1024, just for this specific task. Now we will do some of the changings later on, but for now let's just leave it like this. And after that, let us print the actual message right here. So let me just try this right now. So if I save this, save it, then go and add the code to the actual reverse shell as well. So what we will need to do is actually add another shell function right here, which will actually perform the same thing. So let me just call it down here, shell, and let's call the function or code the function right here. So shell, and we enter the, or not enter the while true loop once yet. We want to type here command equals s or sock.receive. We want to receive 1024 bytes. This is the max value of bytes we actually can receive. So we will see how we can fix that. So for example, if we from the server actually send to the target something larger than the 1024 bytes, or the target sends back to us some value that is larger than this, our program will crash. So later on we will see how we can actually fix this, but for now on all we want to do is simply just get back the message from the target. We want to actually send back, so sock.send, and we can specify here to send hello world. So we will send something to the target, and target will respond back to us with the actual hello world string. So first of all, what we need to do is call the shell function before the socket.close, so we don't actually close the connection before actually executing this function right here. And right now, let us see how this will work. So let's lower this, and let us actually run the server first. So Python 3 server, listening for incoming connections, and Python 3 reverse shell.py. So we are prompted for the command. So let us just type here the command hello. A bytes-like object is required, not string. Okay, so if you get this error right here, that means you're running this with Python 3, which actually is the case. So in order to actually, oops, I didn't want to open the reverse shell, I want to open the actual server. And in order to actually do this, you need to actually encode this with the UTF in order to be able to send this and print the message back. So sock s.send, and we want to send the encode UTF -8 or -8, however you want to call it. And then close another bracket. And right here, we want to print the message.decode, since we are receiving also with the Python 3 UTF-8. And right now, I believe everything should work fine. I run this server, we specify here hello. Okay, let me just check this right here. Okay, so we need to actually change the code in the reverse shell as well. So let's send this in this way. So we will just type it right here. Message.encode UTF-8. And the message will be hello world. So let's see if it will work now. Hopefully it does. Otherwise we'll just switch to Python 2 since it is easier to actually specify this. Encode UTF broken pipe. Okay, never mind. What we are going to do is just run it with Python 2. So what you want to do is just delete this print colored. We will add it later on. For now, it is just presenting us the problem. There is really no point in me just finding the correct syntax for that function just to run it over Python 3. We will just run it over actual Python 2. So we don't waste too much of our time. We don't need this actual encoding anymore since we're going to run it with Python 2. We want to print the message. We want to send the command. So return everything back as it was before. Do that with the actual reverse shell as well. I'm probably missing some library, but it doesn't even matter right now. We're going to run it with Python 2. So let us see. Let me just double check the server as well. Okay, everything should work good right now. And let us run this. No module, name term color. Okay, let me just run this in a hash. Listening for incoming connections. And right now, if I run the reverse shell as well, I need to chmod it first. So chmod reverse shell.py. Okay, connection established. Hello. Hello is not defined. Command equals input. Okay, so we need to change this as well. Since in Python 2 we don't have input, we have raw underscore input. Too many errors. I should just start it with the Python 3 instead, but doesn't even matter. So let's see right now. Let me just check what the actual error is, since we still have some weird error, not really sure for which reason. So we sent the command. Okay, there is the actual error. So this was the error all the time. We need to specify target.send and not s.send, since s.send means we are sending it back to ourselves. So we need to specify target.send. Not really sure how I didn't notice that error. And right now, for the final time, this should actually work. So we run the reverse shell. Hello. And we get back hello world printed out. So we actually managed to finally run this program and get it to work. We send the message back to the target, and the target sent back the reply, which said hello world. So what we will do in the next lecture is we will run this in while true loop, and we will make a simple chat program, which then later on will turn into actually commands, or us sending the commands to target, and target sending us back the output of those commands. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye. Hello everybody and welcome back. And as you can see right now, this is our reverse shell code. And what we want to do is actually try to make it to actually be able to send this hello world message in a while true loop. That means for every string we send to the target will send back this hello world string. So in order to do that, we need to place this in a while true loop. So while true. And we need to tab all of these commands so it can execute them infinitely. So first of all, we execute the socket creation, then we call the shell function, then we close the socket after the shell function finishes. Even though this function will actually be in an infinite loop, so that means that we actually need to code something that will make this quit right after we specify some certain command. So let's say, for example, if we send Q to this reverse shell, it will terminate and it will close the connection. So first of all, we need to receive the command. Then if command equals to Q, what we want to do is we want to break out of this program, and then we will perform the sock.close. In any other case, we will just basically set this message to be equal to hello world, and then we will send the sock.send message to the server. So let us save this. Let us also nano the server part of the code. Since here as well we need to specify a while true loop, so while true. Let's tab everything right here. And we also need to specify that in case the command is equal to Q, so if command equals to Q, we want to break out of this program, or basically break out of this loop. In any other case, we will just specify else right here. So in any other case, we want to send the actual command, wait for the reply, which will be a string of hello world, and print the reply. And after we specify Q, we want to actually close the connection. So s.close right after the shell function. And let us see right now how this will work in valid syntax. So let us see. Okay, so we are missing two dots right here in order to determine the function. Okay, let us run this right here, listening for incoming connections. Let's open a second terminal. So let's let the server be here and the second terminal right here. Let us enlarge both of them so we can see everything a little bit better. And if I go to my Python and then reverse and run my reverse shell, we get prompted for the actual command. If we type ls, we get printed out hello world, who am I, once again hello world, and if we specify Q, we get the broken pipe. Now let us see why we actually get the broken pipe. So we nano the reverse shell right here. Let us actually try to remove the actual shell function for now on, so we can see if that is the actual reason why we are getting the broken pipe. So we just tap everything one step back and we delete this part right here, which is the shell function. We also need to call the actual socket creation before the while true loop. So we will just paste it right here and we will delete it from here. So if we save this program right here and we try to run this once again, since our server-side code worked good, it quitted after the actual Q command. So let's see right now, if we specify Q, we once again get the broken pipe for some reason. So let us see why is that the case. In our server-side code, we sent the actual command. So let us just see. Okay, so the reason is because we actually have to send the command first. Since we didn't send the actual Q command, our target or our reverse shell didn't know that we actually sent the Q. So it actually terminated the connection. It just saw that we, as a server, terminated the connection and it didn't know why that happened. So we need to actually send the command first. So target.send command. The server-side code should be good. So now we know that the problem was not in the actual function itself. So what we can do is we can actually copy this. Now we are doing a bunch of changing the code. So let us actually put this in a function as it was. So def shell and paste all of this code. So right now everything should work good. We actually need to call the function after the socket creation. We will actually right now receive the Q as a command and we will be able to break out of the loop since our code will know that we got the Q back. So let us clear the screen in both of our terminals. Let us run the server once again, run the reverse shell. Okay, so we got an actual error. So while true, let us see what the error is. Okay, so this is not tabbed properly. Make sure to tab it with the tab button, every line right here. That is what the error is about. So I will just delete all of these empty spaces and I will just press tab. make sure to not actually press the space, since you will get the error for your code. So right now, if I save this once again and run the reverse shell, expected and intended block. Oh yeah, since we are in a function, we need to actually tap all of this one step in as well. So just like this. And hopefully after all of this work, we will be able to run the actual reverse shell. So here it works everything good. I specify Q and we quit both programs without any error. So we successfully are able to right now send multiple commands. So all we have to do is actually just check out our server. So the next thing we actually want to perform is actually executing the functions or the commands that we send to the target. Since all our program does right now is it receives a hello world string from the actual reverse shell. That is the server part of our code. But the reverse shell part of our code, right here in the else statement, needs to have some execution of this command that it receives. So for example, if we type ls, it will actually print all of the files in that directory. So in order to actually do that, what we will do is we will import an actual subprocess library, which will allow us to execute any code that we actually want to execute in the terminal. So in order to do that, just type here import subprocess, and right here, the message, we will delete all of this since we don't need this. We will code everything in the else statement from the beginning. We will call our variable where we will receive the output. We will call it result. And there we will store the actual output of this command that we get from the server. But before we do that, we need to create a process. So in order to do that, we need to type here. So just follow with me, subprocess.popen. So we are opening the process, which is the process that is ran by the command that we receive. So it is stored in this variable right here. We need to specify shell to be equal to true, stdout to be equal to subprocess.pipe, stderror to be equal to as well subprocess.pipe. So this is just the syntax for the subprocess library, and std input to be equal to subprocess.pipe. So once we create the proc variable, all we need to do is just take the proc, and from that variable we need to take the standard output.read. So we want to read from it, and we want to also get proc.standarderror.read. And we will store both of these in the result variable, and once we actually store it in the result variable, we can just send or sock.send the actual result. This will happen in every case. Instead of the case where we specify Q, then it will just break out of this loop and it will close the connection as well as the program. So if I just Control O and save this, also check out the server side of code. And let's rename here as well, so we don't want to have message variable. Let us call it result so it doesn't get confusing. And we want to print the result. So our result variable will store the output of the command executed on the target machine. Then we will print that output. So let us see how that will work. We save this. We run this server in this terminal right here. And in the other terminal, we run the reverse shell. We get prompted the shell. It says connection established from this IP address at this port. If we type ls, we can see that we get listed the available files in that current directory. So we know that everything works well. Let's try other commands as well, such as who am I. It says we are the root, such as ifconfig. We get the output of our ifconfig, so we know everything works perfect. Also, if we specify Q, it will quit both of our programs, and we know that we successfully created the reverse shell that is now able to execute commands in the target system. So, for now on, we did a pretty good job at actually creating the server-side code and the reverse shell side code. Now we want to actually add a bunch of different functions, And to fix some of the functions, is there are errors right here, such as, for example, if you wanted to change the directory, you would not be able to. As well as if you wanted to receive the amount of data that is larger than the 1024 bytes, I believe. Yeah, 1024 bytes, which we specified right here. Our program would actually crash, since we are trying to receive more data than we specified our result variable to have. So we need to fix that as well. And we will fix that in the next tutorial. So that will be about it for this tutorial. I hope you enjoyed it, and I hope I see you in the next lecture. Bye! Hello everybody, and welcome back. And in this tutorial, let us see what we can actually do in order to be able to receive and send as much data as we want. So for example, some function, or not some function, some command will actually retrieve a larger amount of bytes than the 1024 bytes. For example, some netstat command could be retrieving like 2000 bytes or something like that. So we want to actually fix it so it can receive any amount that the command output is. So we will add two different functions right here, which we will then need to add in the reverse shell as well. So for now on, we will call the send function reliable_send. And what we will paste in that function is the actual data to send to the target. All we need to do right now is import a library which will allow us to finish our process with these two functions. And basically, let me just add another function which will be reliable_receive. This function will be used to receive data. And we will use JSON in order to perform this process of sending and receiving as much bytes as we want. So in order to send the data, we need to create some variable which we can call JSON_data. You can call it anything you want, but it needs to perform the dumps function, so JSON.dumps on the actual data that we specified as an argument to this function right here. So after we do that, we can just simply send the actual data with the same sock.send function, or not sock, in our case should be target.send, since we specified the target to be the actual socket object for the target machine. We need to target.send, and what we are sending is the JSON data. So this is the actual entire sending function, and we will be using this reliable send function to send any data from now on. We will not be using target.send anymore in any case. Now we want to code the reliable send. We need to also make a variable which we can just call data and specify the data to be empty. So we specify that just by opening double quotes and closing double quotes right after. Make sure to not have space right here, otherwise this will actually give the empty space to this variable. We need to open the while true loop in order to receive the data for as long as there is something to receive. So what we will try to do is we will try an except rule, which will allow us to actually receive. So if I just type right here, data equals data, which will be empty data, plus target.receive. And we want to receive 1024 bytes. We close the brackets, and we actually want to return JSON.loads function. So that is a function in the JSON library from the data that we received. So in any other case, or if we get any error, we want to actually use the except value error. Now let me just write this and I will explain what this means. We want to continue the process. So let's explain this function so you can understand it a little bit better. What we did right here is, first of all, we created a simple variable, data, which is empty. Then we entered a while true loop, and in this while true loop, what we will do is we will try to receive the data. We will try to receive 1024 bytes, and we will try to return that data to the actual shell function right here. In case we get any error, or not any error, in our case value error, which means that we actually trying to receive less bytes than the output of that command was. So that means that we actually still have some bytes left to add to this data. What we will do, we will then continue, which will go to the beginning of our true loop, and then it will add those remaining bytes to the data. And it will perform all of this until the entire data has been sent and stored in this data variable. Then we can return the data variable and print the output of that command. So one thing we need to make sure as well is right here, instead of using this target.send right now in our shell function, we need to use reliable_send to send the command. And in order to receive the actual output, we need to use reliable_receive and make sure to remove the 1024 bytes, since our reliable receive doesn't take any argument in the brackets, so we will not specify anything right here. Everything else can remain the same. So let us save this program and let us copy these two functions, since here we will actually paste same functions in the reverse shell side of code, just we will do minor changes to that part of these, or to the part of those functions where we specify the sending and receiving. So paste these two functions in the reverse shell code and change every target.send and every target.receive into actually sock.send and sock.receive. Since the target variable is not actually something we have in the reverse shell program, so make sure to specify right here sock.send JSON data, and right here make sure to specify sock.receive. And also in the shell function we need to specify that command equals reliable_receive. We want to receive data with this function, and we want to actually, let me just see, send the result with the reliable send. So right now, if we coded everything successfully without any error, we should be able to send and retrieve any amount of data that the user or that the target sends back to us. So let us save this. Now let's test our program to see if it works. Let me just put this down here. Run the server. We are listening for incoming connections. Then run the reverse shell. Let's execute ls. Global name JSON is not defined. Okay, so in order to fix that, the reason why the global name JSON is not defined is because in our reverse shell code, we forgot to import JSON library. So make sure to have imported JSON library in both server and reverse shell code. And let us run it once again. Okay, server already, or pardon me, address already in use. We will just restart the terminal as I showed you before. Once you get that, just make sure to restart the terminal. Run the server once again. Run the reverse shell. Execute, for example, ls. It works. ifconfig netstat.-nr works as well. Whoami works. So basically anything that we do now works. We will be able to receive any amount of data, and our program will not crash if the data is bigger than 1024 bytes. Let us specify Q in order to close the connection. We can see it worked perfectly, and our program is now even better than it was in the previous video. We got a fully functioning reverse shell that can only execute commands from now on, but what we will do from now is actually specify some different things that our reverse shell will be able to do, such as, for example, download files, upload files. We will try to perform the connection every certain period of time. We will also try to perform the screenshot function that will actually screenshot the target's PC. We will also check for the user privileges or administrator privileges, and we will see how we can hide our program or our backdoor somewhere where the user will never find it. So hope you enjoyed this tutorial, and I hope I see you in the next one where we will continue coding. Bye! Hello everybody and welcome back, and in this tutorial what we are going to do is we will actually try to perform the first test of our reverse shell. So this is our first test right after we saw how we can execute commands on the target system. Now let's try to actually test this on our Windows 10 machine before we start adding any new functions we might need and any new libraries that we need to import. So let's see how we can compile our reverse shell, since right now if you see, let me just delete the server.save. Okay. Since now you can see that we have the reverse shell.py, which can't really be executed on Windows target system unless the Windows target system has the Python interpreter. But we know that what we can execute on the Windows target system is the actual executable files or .exe files. So let's see how we can make our reverse shell.py to be an actual executable. So let me just delete this socket as well, not really sure what that is. And let us right now use our Wine in order to actually compile this program. So what we want to do is, first of all, go right here and just type this command as the same command as I will. So wine/root/.wine/drive/c/python27/py installer /python27/scripts/py installer. And then after that, once you specify that we want to use the py installer library in order to compile this, we need to specify some of the actual additional options that we want our reverse shell to have, such as we want it to be one file, which you can specify with double dash and then one file right after it, and then double dash no console, which will specify our reverse shell not to prompt the console open once it starts the file, which can be a little bit of actually weird if our target actually gets prompted a console, so we want to make sure to remove it from this program. Then right after you specify all of this, you need to specify the name of the program that you actually want to compile, which in our case is reverse shell.py. Press right here enter. This will take a few seconds to compile, and you will get some directories right after it in this reverse shell directory, from where we will get our executable. So then you can actually use any type of delivery method you want. Let me just show you. If you just type ls right here, you will have this build directory, this directory, and this reverse shell.spec directory. Your actual executable will be in the dist directory, so just type cd dist. And if you type ls once again, you can see there is reverse_shell.exe. That is our actual executable. And let me show you how you can actually transfer it via USB drive. So just plug in your USB drive. And your USB drive will be plugged into your main machine, as you can see right here. What you need to do is, first of all, let me delete the previous reverse shell from here. Actually, I can delete all of this, don't really need it at the moment. In order to actually import the USB drive into your Kali Linux machine, you need to go up here on Devices, USB, and find the name of your USB drive and just click on it. In my case, that is the Kingston Data Traveler. I'll just click on it, and right here, it should be imported into my actual Kali Linux. As we can see, it is imported right here. So in order for me to copy that file or the reverse shell to the actual Kali USB drive, I just need to specify move reverse shell to the media, root, and then Kali Live, which is the name of my USB drive. So this is the path where your USB drive is or will be imported. So /media/root, and then all you have to do is afterwards specify the name of your USB drive. Then if I just click here enter, it will move the reverse shell.exe to my USB drive, and after this finishes, I can just eject my USB drive and paste the actual reverse shell to my Windows desktop environment. So this is taking a few seconds, since this is probably the first time. Okay, so let's wait for this to finish, and afterwards all we have to do is just run our server on our Kali Linux and run the reverse shell on our target system. Okay, so it has finished. You can see if I just type ls right here, there is no longer reverse shell.exe in my directory. And what you can do right now is delete all of this that you got during the compilation program. So we can delete the build directory with rm-r, we can delete the dist directory with rm-r, and we can delete the reverse shell.spec. All we need to do right now is run the actual server.py, and we can now eject our USB drive, go right here, paste the reverse shell onto my desktop on my Windows 10 machine, and then if I just double click this, you can see nothing really gets prompted to the actual target, it will look like this program didn't run at all and didn't open anything. But if we go to my actual Kali Linux machine, we can see connection established from the IP address of my Windows 10 machine from this port. In order to make sure that this really is my Windows 10 machine, in case you doubt, we can just type ipconfig in my command prompt on my Windows 10, and you can see the IP address of my Windows 10 is 192.168.1.4. So we successfully got the connection from the Windows 10 machine. Let's see if we try to execute some of the commands, such as, for example, ipconfig, the same from our terminal. We can see the results from ipconfig, dir, which will list all the actual files on my desktop. As we can see, the path is to my desktop. These are all the files on my current desktop directory, as you can see right here. So for example, you can just make dir, so I'm not really sure, I believe it is make dir, test1, you just execute that, and we can see right now on my desktop there is a directory called test1. If we wanted to, we can delete the test1, so we just type del test1, but that is a directory, it might actually cause some problem. Okay, yeah, it will cause a problem, doesn't really matter, you can see right here it will hang. We will see how we can fix that in the future tutorials, but right now we can see that we successfully compiled our program and we can successfully execute some of the commands on our target system. What we will do in the next video is we will continue fixing our program. We will see how we can actually change the directory from the desktop to some other directory as we like, and we will also see how we can execute some of the commands that present us the problem, such as, for example, this command. Also, if we actually try to specify to delete a file that doesn't even exist by making a typo or just not specifying the correct name of the file, our program will right now crash in case we do that. So we will see how we can actually fix that as well, so we don't actually lose the connection, just like we lost it right here, while trying to perform some task. So hope you enjoyed this tutorial, and I hope I see you in the next lecture where we will continue coding. Bye! Hello everybody, and welcome back to our reverse shell coding. So in the previous video we saw how we can actually run our commands in a while true loop, and also how we can execute the commands on the Windows 10 host. We tested our shell while after being compiled on our Windows 10 machine, and we saw that actually everything works well except some certain commands that cause our actual shell to crash. So the first thing we need to fix is the inability to actually change the directory once we run our reverse shell. So in order to do that, we need to import a certain library, which is called the OS library, which will allow us to use a function called change directory in order to perform the changing of directory in our reverse shell. So first of all, go up here. Let me enlarge this one so you can see it a little bit zoomed in. And we want to import OS. The OS library is standard library in Python, so we will not need to pip install it in order for this to work. What we want to do right now is perform an else if statement right here in the shell. So what we have for now, if the Q command is specified, this will close the program. In any other case, it will execute the command in the command prompt. But we do not want to execute this in the command prompt, so we will add an else if statement, and in order to specify the actual changing of directory, we need to know how it actually looks like once you change directory in Windows 10 machine. So in order to do that, open up your command prompt, so cmd, it is same for every Windows host, and currently we are in this directory. So for example, let's say I want to go to my desktop directory, I will do that with this command, so cd desktop, and then you can see my directory is now changed to the desktop directory. So right now we know that the command for changing directory starts with these two letters, which is cd, which basically just stands for changing directory. Same if I wanted to change the directory back, I can do this like this with cd two dots. It is rather same in Linux as well, so basically those two commands are the same, or this command is the same for Linux and Windows. So let's see how we can specify that in our program. We know that the command will be received in this variable right here, so we can actually filter it out with this statement. So else if command, and then in the square brackets we will specify the first two letters, like this. So if first two letters, whoops, not space right here, are equal to CD, and length of the actual command variable is bigger than 1, then we will use a function called os.changeDir. From the command, from third element or from fourth letter in our command to the end. So now you probably, if you're new to this, have no idea what I just typed right here, so let me explain. Once we actually type the command to change the directory, it will look something like this: cd space and then the name of a certain directory. Let's say, for example, cd desktop, as from the example in command prompt. Now we see at this we look at this statement right here. So this statement right here is satisfied. The command, actually the first two letters of the command are indeed the cd. Now this statement right here also needs to be satisfied in order to proceed with changing directory. The length of the command variable has to be bigger than 1, which basically stands for, since we know the counting starts from 0 in Python, the length of the actual command has to be bigger than two actual letters. Now why is that an actual statement? Well, if you open up your command prompt, and you will see that if you just type cd, it will just print the working directory. So cd and cd desktop don't do the same thing. Just cd only prints the working directory, and the cd desktop changes the directory. So we need to specify right here, once there is actually something else specified after cd, then we want to change the directory. Then we proceed to this statement right here, which basically stands for change the directory to the directory that is specified in the brackets. And in the brackets is specify command from the fourth element to the end. Now we can count right here. The C is first element, the second, or basically third element is the empty space, and the fourth element will be desktop. From the fourth element, it will be desktop. So in the brackets, basically you can just imagine it says right here desktop, or the name of any other directory you want to change. So that's how this changing of directory works. So let me just delete this right now. But just in case, we actually want to run this in a try and except rule. In case, for example, user specifies the directory with a wrong name, we don't want our reverse shell to crash, so we will just try and accept. We will accept, and in any case where the user actually specifies, for example, directory that doesn't exist or any error occurs, we will just continue with the program. So basically this is the entire code we need to specify right here. Let me just check this out. Okay, everything seems to be goodly specified, and all we need to do is right now save this and nano our server code, since there we need to code something as well. So right here we can code, since you will see that if we actually send the cd command, we will then proceed to this statement right here, which will then wait for a certain bytes to be received from the target. And with cd command we really don't receive anything, since there is no output to that command, we just change the directory. So right here we need to specify something that will just go back to the beginning of the loop. So we can just use else if the same, so the same as in the reverse shell, so command and first two letters are equal to the cd, and length of the command is greater than 1. Oops, let me just add space right here. All we want to do is just continue with our loop, which will basically just go at the beginning of this loop. So let us save this. Let us compile our program to see whether this will work. So wine, then we need to specify the actual path. So wine, root wine, drive C, Python 27, scripts, and then pyinstaller.exe in order to compile this, -- no console, and -- one file. And then the name of the file that we are compiling, so reverse_shell.py. Make sure to still have the actual USB drive, since we will perform the same task as before. Right now I will just not explain what I'm doing. basically do the same as before in order to transfer the actual reverse shell.exe onto the desktop on your Windows 10 machine or any Windows machine you're running. Let's wait for this to compile. It should take just a few seconds. So we go to this directory. There we are going to have our actual exe file. We import our USB drive. ls, okay, there is our exe file. And now I move my exe file to media root Kali live, which is the name of my actual USB drive. Now right here, of course, you will not have this name. You might have a different name for USB drive, so make sure to specify it. As soon as this actually transfers, you can unplug this. Go on to your Windows 10 machine. And I can just transfer it on my desktop. Now before I run the reverse shell, I must run this server. So let me just delete the unnecessary directories that we don't need anymore. Same as in the previous video. And I will run my server. Now after that, I will run the reverse shell.exe. We can see nothing is really opening right here. There is nothing being prompted. But if we go right here, we received the actual connection. So we know that we are in the actual desktop environment or desktop directory. So let's see if we can change the directory. We will create a directory called test. We can see on our desktop right now it is created. And let's try to change the directory to test directory. And if I just tap there once again, there is nothing here because our test directory is empty, but we can see that we are currently in the test directory. If I go one step back and another step back, so that means that I will be in the actual directory, which is one step before the desktop directory. So you can see our actual changing of directory works really well. We can change to any directory we want. So basically our program works fine now. What we will do in the next video is we will see how we can actually download and upload files from the target PC and to the target PC. So hope you enjoyed this video and I hope I see you in the next one. Bye! Hello everybody and welcome back, and in this tutorial we are going to see how we can code a part of our server and reverse shell in order to be able to download any file that is stored on the target system or upload any file that we want from our Kali Linux machine. So we will need to specify a few different things in order to be able to download any type of file, such as exe files, pictures, mp3 files, VBS files, and so on and so on. So let us see how we can do that. We will start off with our server code. So nanoserver.py. For now on, all actual options we have is the queue option, the change directory option, and the actual executing of command option. So what we want to do is add the upload and download option, and we can do that the similar way as we added the CD option. So what we will do is we will code another else if statement. So else if, we will add the command, and first of all, let us add the download command. So let's actually think how we can specify this. Well, we can actually specify the same as CD. So first first 8 letters, since that is how many letters download word has. If the first 8 letters are equal to download, then we will see what we will do. So first of all, let's see how our command will look like. I will just write it right here. So for example, let's say there is a test.txt file on the target desktop. So let us create it. We can just use notepad. Hello world, exclamation mark. I will just save a file on the actual desktop. So we will call it test.txt. I save it, I close this, and we can see our testing file is right here. So we will try to download this file from target PC. So what we need to do, first of all, the command will look something like this. So download test.txt. We checked if the first 8 letters equal to download. If they do, then what we will do is, first of all, we will open a file on our Kali Linux machine with the same name as the file on target machine, and we can specify the same name to be as from the command variable and from the 9th element to the end, which will basically stand for it will cut out the first 8 elements, which will be the download word. Then it will cut out the empty space, and it will basically name the file what is the remaining, which will be test.txt or any other file name that you try to actually specify. So this is the name of the file. The second argument of opening files is how we want to open them. So we want to actually write to a file on our Kali Linux machine, and we want to write bytes. You specify that with W and B. Basically, W stands for write and B stands for bytes, and we close the brackets. So these are the two actual inputs that the file creation in Python takes. Now we need to specify as which file descriptor we want to open it, so we can just call it as file. So simply just call it file, it doesn't even matter. And then once we do that, once we actually open the file, we want to receive the data from the test.txt file on target PC. So we will just make a variable called result, even though we already have it right here, but this is the part of code that will not be run once we actually run this command. So we need to specify another variable right here. We'll call it the same result, and it will be just result underscore receive. Or if you want to, if you're actually getting confused by two same named variables, we can just type here file result or file data, let's call it like that, file data equals result underscore receive. And then what we want to do is write to this file that we opened right here, which is saved on our Kali Linux machine. So file.write, and in file.write, we need to actually write this data that we received. But in any case, in the case of this file actually being a text file, we can just simply specify here file data. But for example, if we try to download a picture, we would need to first of all base64 encode the picture before sending it from the reverse shell, and in our server code, we need to perform the base64 decoding of that picture. Now, we will use the base64 library in order to be able to download and upload any file we want. So we'll just import base64 so our program doesn't crash. And in order to write right here, we will need to perform a decode function, since in the reverse shell later on, we will perform an encode function. So right here, instead of file data, between the brackets, you need to specify base64 dot b64 decode, and in the actual brackets, open and close another brackets, and specify what you want to actually write, and we want to write file underscore data. So this is basically everything we need to specify for the actual download function right here. As we can see, we open the file to write bytes, we received the data in this variable file data, and we wrote the decoded file data, which we will encode later on in the actual reverse shell. So that will be actually about it for the download function. Let us code right now the upload function for our server. So we will start off the same. Let me just delete this download test.txt, since I will forget to delete it later. And right now what our command will look like is upload test.txt. Just right now this test.txt will actually be on our Kali Linux machine, and we will upload it to the Windows 10 machine. So else if, oops, not here, we want to code down here. Else if command, and we count how many letters upload has. It has 6 letters, so first 6 letters of the command are equal to upload. What we want to do is basically, first of all, open a file. So open a file that is already on our Kali Linux machine. So right now, instead of actually opening a file in the download function, we need to open it in as reading. So we want to read from that file. So with open, and then a command, we want to name it the same as from the actual command itself. So from the 7th character till the end, which will just leave the test.txt as a name, which is right now important since it will not open a file if we don't specify the correct name. So then make a comma, and how we want to open it? We want to open it to read, and we want to read bytes. So RB between double quotes, close the brackets, and we can call this one fin. It doesn't even matter, you can call it anything you want, as long as you make sure that later on you specify the write and read function the same name. So we open the file, and what we want to do right now is actually send the contents of this file. So we will reliable underscore send, and now since we are the ones sending the data, we need to encode it before sending it. So we will use base64.b64 and now encode, and not make sure to make a difference between the decode and encode. Don't type both of them the same. And right here, once you encode it, we want to send the actual fin.read, open and close bracket, since this is a function, and close another bracket from the actual reliable send function. So we successfully send the file, but make sure to add a try and except rule right here, since we don't want our program to crash if we, for example, specify the name of the file that we want to upload to target PC, the wrong name. We want to run this in a try and except, so try, then tab these two, we will try this, and then we will accept. If any error occurs, we will just basically send to the target a failed variable, which will contain a string which will say failed to upload, which we can then check. If we get the target, the actual target file, we will see that it says failed to upload, and we will know that something is wrong with the actual upload function, or that we specify the name incorrectly. And all we want to do is reliable send the actual failed string. So we can use base64 once again, since we need to encode it. Base64 encode failed. So this is the entire download and upload function in the actual server. Now what we want to do is basically just code the same thing in the reverse shell. So in order to not type this twice, I will just copy this. I will close the actual program, save everything, save it under that name. Let me just check if I saved everything correctly. Okay, I did. Then I go to my reverse shell, and right here under the actual change.go directory, I can specify what I copied from the server code. But of course, we need to change a few things right here. We cannot leave it just like this, since the download and upload function will not be the same in our server code, or pardon me, in our actual reverse shell code. So let me just check here. If we get the command to be download, that means that our reverse shell is receiving, or basically it is sending the file. So we first of all need to change this write bytes to read bytes in download in the reverse shell. We can leave it to be named the same. And we are not actually receiving the data, we are sending the data. So let us delete this. Let me just go right here. And what we want to actually do is basically reliable send, or we cannot leave it like this. This is writing to a file, so let us do it like this. Reliable send, open and close brackets to our function, and send base64.b64 encode. Since in our server we decoded the download function, right now we need to encode it in order to send it. We open the brackets, and we are sending the file.read, open and close another brackets, and close two other brackets. Since make sure to have 3 brackets open and 3 brackets closed, so you don't run into an error. And all we are left to do before testing our program is to fix the upload function as well. So in the upload function, first of all, we need to fix the actual RB to be write bytes, since in our target PC we are now writing the file that we are receiving, and all we have to do is just receive the actual file. So we need to delete this first of all. We don't need the try and except rule right here, there is no point. So let us delete all of this, and then we will write what we need. Also delete the try. And let us see what we need to do in order to make the upload complete on our reverse shell. So what we will do is file data will be equal to reliable underscore receive. So what we are doing is we are receiving the file data, and we want to write, so fin.write the base64.b64 decode, and what we are writing is the file underscore data. So if I'm not mistaken, everything right here should be Good to go. And right now, if we save this and compile the actual program, let me just find the command from the previous video, so I don't type it once again, just actually compile it with the same command as usual. Press enter. We let this compile, takes a few seconds, and right now let us see if we are going to be able to download this test.txt file, as well as upload some file that I will create right now in our Linux environment. So let us just wait for this to compile. We can right now import the USB drive, go to my disk directory where my actual reverse shell.exe is, and move it to my media, root, and Kali Live, which is my USB drive. So we wait for a few seconds. Okay, so it has finished. I unplug the USB drive. Let's paste the actual reverse shell to the desktop. Now make sure once you're actually downloading and uploading the files, you can only specify only the name of the file once you're in the same directory as that file. For example, if this reverse shell was one directory back and not on the desktop, you will need to specify the full path to this test.txt file in order to be able to download it from a different directory. So, before we actually run our program, let me go one directory back, delete the dist, delete the build, delete the reverse.spec, and before I run my server, let me create right here in this directory a file which we will call hello.txt. And we will type here hello there. We will save it so we can have it right here, and then we will try to actually upload it to the target PC. So let us run this server, upload test.txt. Okay, so in my server code, what I forgot is to remove this line. And there is also another thing that I think I forgot, which is unfortunate, but we will have to actually fix it. Yeah, I didn't import the base64 library right here, so make sure to import it. Import in reverse shell.py, and right now I will compile it once again because our program will not work. The one that we actually pasted on our desktop, I will just delete it. It will not work because we didn't compile it with the base64 library. So I will compile it once again, just give me a second. I will plug in my USB drive real quick in order to transport this reverse shell.exe to the target. Okay, change to dist, move reverse shell to the media root Kali Live. Sorry for this, forgot to add the base64. Make sure you add it as well, otherwise your program will not work without that library. And we are good to go right now. So let's run our server. Okay, so we have an actual error. Let me just find it where it is. Except, why is there an error right here? Not really sure. Oops, what am I doing? Okay, it could be because we are missing something somewhere. For example, right here, we are missing another bracket in our server code. So make sure to add a third bracket right here. And right now, if we run this, everything works well for now. So let me unplug my USB drive from the Kali Linux machine. Then paste the reverse shell to my desktop once again. And I can run it right now. So hopefully if everything worked well and we coded everything well, our reverse shell should connect back to the Kali Linux as it did. So let us check some usual commands such as who am I, and basically dir for actually listing all the files on the actual desktop environment. And right now, let's first of all try to download this file to our Kali Linux machine. We, for example, saw an interesting file, which is test.txt. So let us type download space test.txt. We press enter. Result underscore receive is not defined. Oops, so we named something not really correct. So let me just try it once again. Let me just remove all the unnecessary directories so we don't actually confuse ourselves with them. So somewhere I specified result.receive instead of reliable.receive or underscore receive. Let Let me just find it where it is. Okay, so here is the error. It's not result_receive, it is reliable_receive. Let me just clear the screen, run it once again, run my reverse shell once again. It connected back, there, works, and let's download test.txt. Okay, so it seems like we didn't get any error. If we run another command, we can see we can execute further commands. So we hope that we actually downloaded the file successfully, which we will change as soon as we terminate the connection. But before we terminate the connection, let's try to actually upload to the desktop the hello.txt from our Cal Linux machine. We can see right here there is nowhere hello.txt file. So if we go right here, type upload hello.txt, we press enter, everything seems well. If we go right here, there is now hello.txt file, we open it, and it should say hello there, as it really does say. So our upload function works. Now let's terminate the connection with Q and type ls, and we can see our download function works as well, since we have the test.txt file right here. If we cat the test.txt, we can see it says hello world ! Which indeed it does if we open it right here. So our upload and download function work really well. We managed to code them, and in the next video we will code some different functions useful for our reverse shell. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody, and welcome back to this tutorial. And right now what we are going to do is we will see how we can hide our reverse shell. So in the previous videos we saw once we actually ran the reverse shell, it was rather here on desktop, and the user could simply just delete the file as soon as they run it, right after they close it with Task Manager. So they would be like, why is this file not running? It's not opening anything, I do not need it, and then they would delete the file. But what we can do is as soon as they actually open the file and run it, we can actually make a copy of that file into a different directory where they will never find it. So for that directory, we will use a hidden directory in Windows called the app data directory. We will hide our copy of our reverse shell there, and then we will try to create a persistence which will allow us to actually run our reverse shell right after the target restarts their computer. So basically what we are doing in this video is we are hiding the program and also creating the persistence for our backdoor. So let's see how we can do that. In order to do that, we will need to import a library in order to copy our file. So let us nano the reverse shell first of all, and import a library which is called shuttle. So import shuttle right here. And where do we want to actually create the persistence itself? We can actually create it at the beginning of the code. So before it even connects back to us, it will perform the copying of the file, and then it will connect back to us. So what we can do is we can create a variable called location, which will store the location to the new path of the actual place where we want to copy our backdoor. So we will specify that place with os.environ, and in the brackets, in the square brackets between the double quotes, we need to specify app data. What this will do is it will find the app data path on our target PC or on our Windows PC. Now make sure once you run this reverse shell, it is a Windows target, because app data folder doesn't exist in the Linux systems. So let me show you where it is. If you open your command prompt and at your path of your user, just there you can just type cd app data, and you will be in the hidden directory. There you can just type dir, and you will see some different directories as well. Now the path where we are going to actually save our hidden or our copy of our backdoor will be in the roaming folder in our app data path. So this is basically the path of app data, and this function os.environ will return this path right here. All we need to add to this location is the name of the file, so we can add it like this. Plus, since we can concat the strings in actual Python, we specify right here // in order for this to actually work, and we can name the copy of our file anything we want. So let's name it, for example, windows32.exe. Since that looks something or it basically looks like something that could possibly exist on target PC. So even if the victim or the target actually found this file somewhere, they would probably not worry about it since it pretty much has a normal name. Now you can call it anything you want as long as it has .exe extension, and make sure to close the double quotes right after it. So right now what we are going to perform is checking if this location exists right after we run the program. Now the reason why we are checking if this location exists is basically what happens if we actually run this file twice on the target system. So in the first time it will actually create this path with the file right here. We do not want to create it a second time. We only want to create it once. So in order to do that, we can just type here location, or not location, we can just type if not os.path.exists, and this function will basically check if a certain file at the specified path exists, and our specified path will be location. So if it doesn't exist, we want to create it. In order to create it, we can just use shuttle.copyFile, which is a function that will copy a file. Now we want to copy our executable, which we can specify with the sys.executable. It will specify the actual executable that is running in this program and the comma, and then we need to specify the path where we want to copy it. We want to copy it in location. Now in order to use sys.executable, we need to also import a function called sys, or pardon me, not a function, a library called sys. So once we copy the actual file, we want to create the persistence. Now this is an optional, you don't need to create the persistence if you don't want to. I will show you how you can do it. There is one command which you can run in your command prompt to create persistence, which will basically add a registry key to your Windows 10 machine. So let us do that. So subprocess.call. In the brackets right here, since we are using subprocess.call, what this will do is it will execute the command. We need to specify this command, so just type everything. I type open single quote, reg add hkcu capital backslash software backslash Microsoft backslash Windows, and then backslash current version, and once again backslash run. Then space, then normal, whoops, not space outside of the bracket, so space, the normal slash small v, then the name of the actual registry key that you want to create. So I will just call mine, in this case, backdoor. Doesn't even matter, call it anything you want as long as it is one word. Then the type of the registry key we are creating, it is reg_cz. I will show you later on where you can find all of this. We also need to specify the /d option, then close double quotes, then close single quotes, then add the actual location with the plus, so we can concat a string. So plus location, plus, and then single quote, double quote, single quote. And then comma, shell equals true. Oops, T has to be capital. And this is the entire actual command. So what this will do is it will create a registry key, which will make our file run after every restart. It will create a registry key at this path, so it is a registry key at the current user host key, or pardon me, H key current user. Let me just show you how to get there. You just type in your search bar right here. You can type run, and it will open up this small window where you can type regedit. It will prompt you for the administrator password. You just, since I don't have, I will just type yes, and it will lead you to a page like this where your registry keys are. So we can see we created in the H key current user, since H key cu is the name of our path. Now make sure to not delete anything from here that you don't know what it is, since it can actually crash your PC. So right now we go to the same path that we actually specified right here. We click on HKCU, we want to go software, Microsoft, Windows, current version, and then run. So let us go H key current user, software. Then we need to find Microsoft, which will be under M. So let me just find where M is. Here it is. Then what we are finding is the Windows. Okay, so here it is. Current version, and then run. And right here is the place where we actually want to create a registry key. And basically this run path right here, here are all the files or all the programs that will run once you actually restart your PC and log in to the same account on your Windows 10 host or any Windows host at all. So basically, once we actually run the program, right here we will have something called Backdoor, which will be the type of reg_cz, and the data will be the path to our file that we copied. So it will be the path to the app data folder where we have windows32.exe file, which is basically just a copy of our backdoor. So let us just tab this down. Let's see what else we need to type right here. Basically, this is for now on enough. We don't need anything else. Let me just check if this command is good enough. Then we proceed to create a socket object and then we enter the shell. So let us see if I save this, exit. Now we want to compile the program once again. So wine/root.wine, drive C, Python, and then scripts, PyInstaller, -- no console, and -- one file. Now we don't need to fix anything in the server code, since this is something that will only run in the actual reverse shell. Now here it is prompting me this because I forgot to specify the file that I need to compile, which is reverse_shell.py. Okay, so we will see how this will work. Right now we don't have anything named backdoor right here. And also if we go to our app data roaming folder, so open your command prompt, go to your app data, which you can just go to your actual user account and then see the app data and then see the roaming and type dir right here. Right here is where we will have our windows32.exe copy of backdoor once we execute the reverse shell or once the target executes the reverse shell. So let's leave this open as well as this open, and let's unplug our USB drive in order to transfer the actual reverse shell. So let me go to this directory, move the reverse shell to media, root, and the actual USB drive. Let's see, why is it not plugged in yet? So USB, let's unplug it and plug it again. For some reason it won't plug in. Okay, so let's wait for it to plug in. There it is. Right now if we move the reverse shell to media, root, Kali live, takes a few seconds. You can also transfer this reverse shell over Apache 2 web server if you want to, whatever you find easier. For me right now I will just use the USB drive because it comes pretty handy and I believe it is faster, maybe not. But just make sure that you know that once you actually download the file from the internet or from the Apache 2, it will prompt user saying this is an exe file, would you like to run it? But that actually comes with every file that is actually exe download from the internet, so it doesn't have to do anything with the viruses, so don't worry. Right here we want to go one directory back and run our server.py. Let us actually remove the USB drive. Type right here, or put it right here, and then run it. Let's see if our reverse shell.exe will work right now. So as soon as it connects, and it already did connect, we can execute commands. So what this means that it already completed the process of copying the file and creating the persistence with our registry key in our HKey current user registry. So let us see. First of all, check the command prompt. Right here you cannot see any windows32.exe folder or file. If you type here once again, let me just find it. Here it is. So right now we do have a windows32.exe, which is a copy of our backdoor. And if we go to our actual registry edit, when we refresh with F5, we can see right now we have a new registry, which is the backdoor. It is called backdoor. Now you can call it anything you want, just specify in the actual reverse shell the different name. If you think this is actually noticeable, which indeed it is, and we can see the path to the program that it will run at the startup, which is the path to our windows32.exe. And right now, even if the actual target took this reverse shell and deleted it, and even if they shut down their PC and turned their PC tomorrow, or in 2 weeks, or in 2 years, you would still be able to connect back, or basically to connect to their target PC and execute the commands. So let's just close this since we don't need it. Even though, let me show you, even after you actually delete this, so it is deleted, but it will still remain in here. So that would be about it for this tutorial. We saw how we can successfully create persistence, we hid our backdoor into a different file, and in the next video we will see some of the different options we can actually add to our reverse shell. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody and welcome back, and in this tutorial we are going to see how we can actually perform the connection to the actual server every 20 seconds. So you might have noticed that every time we actually tested our reverse shell, we needed to wait, for example, before we actually ran the reverse shell, we had to set up our server in order to connect back. Now what, for example, if our target suddenly opens the reverse shell without us listening for a connection? It will not be able to connect back to us, and it will basically just close the program, and we will not be able to execute the commands or do anything else to target PC. So we want to implement something in our reverse shell which will try to connect back to our server basically every 20 seconds, or doesn't have to be 20 seconds, it can be any amount of time you want to specify. So in order to do that, let us go to our reverse shell. Oops, let me just delete from the previous compilation unnecessary files and folders. So we can only have these two files. Let us also delete the hello.txt and test.txt. And let us nano the reverse shell.py. Right here, what we want to do is, instead of this connection right here, first of all, what we want to do is delete it. Since we don't want to connect right here, we will make a simple function which will do that for us. So just delete this right here. Oops, not everything. So socket.sock_stream. Okay, and right here, we will basically just call a function which will be called connection. So this function is the function that will perform the connection. Just go up here, right here, go up, and we can code the actual function right here. So def connection, open and close brackets, let's add the two dots, and in order to be able to actually execute the connection every 20 seconds, we need to run this in an infinite while loop. So while true, we will add something called sleep, which is a function that comes in the time library, and in order to use it, we need to import time. This is a library which will allow us to use this sleep function, which will basically just not execute any part of the code for the specified amount of time. So this sleep function actually takes one argument, which is the amount of seconds you want your program to sleep. In our case, we will specify 20 seconds, and after that, we can try to connect. So try sock.connect, open double and open double close brackets, and between the double quotes we need to specify the IP address, which in my case is 192.168.1.9, which is the IP address of my Kali Linux machine. Then comma and the port that we are listening on. So in my case 54321. And after that, once it connects, we can actually enter our shell from here. So if we are entering our shell from here, we don't need to have the shell specified right here, so we can delete the calling of the shell function from here, and we will call it from the actual connection function. In case it doesn't actually manage to connect, that means that our server is not open and running, and it is not listening for connections. So in that case, we will call connection function once again. So this is a recursive function. It basically calls itself. As you can see, we call the function connection from the connection function, and this will go in circles until it manages to connect to our server. So for example, if someone ran this reverse shell and then 3 hours later you actually opened and started your server, it would actually connect to it even 3 hours after running the reverse shell. So let us save this. Time sleep, 20 seconds, everything is good. We can now try to compile the program. So whine root.whine drive C python 27 scripts by installer. Okay, so now console one file and then reverse_shell.py. Let's press enter right here. Let us import the USB drive. And right now what we are going to do is we are going to run the reverse shell first, then we will wait a few seconds, and then we will run our server in order to see whether it will connect or not. So let me just go right here, go to dist, and move the reverse shell to my USB. Also, since we already have from the previous video the copied backdoor into our roaming folder and also a registry key in our registry editor, this reverse shell right now will not perform the persistence since it already performed it in the previous time we actually ran it, as you can see in the actual code. So let me just go right here. It is good to know that .py. You can see that we coded right here that it should not perform these two commands in case this location right here exists. So since it does exist, since we coded it last time and we actually copied it, it will exist and it will just skip this part right here and it will go straight to the socket creation and then connection function. So that is good as well. Let us run our server. Let us unplug the USB drive. Copy the backdoor or the reverse shell to the desktop. Run it. Oops, we actually made a mistake. Let's wait for it to actually connect. We should have waited 20 seconds and we should have ran the reverse shell first. So what I will do is I will just close as soon as this connects. I will just press Q to close the connection and then I will start the reverse shell once again and just basically wait a few seconds before starting the server. So I quitted the server. Let us start the reverse shell once again. Okay, so it is started. We can see nothing is opening, nothing is running. Basically right here we don't have our server opened. Now let's wait a few seconds and actually start our server. So clear the screen. There wasn't really point to clear the screen, but doesn't really matter. And let's right now run the actual server. It is listening for incoming connections even after we run our reverse shell. And right now, hopefully, we will get connection back. So let's wait a few more seconds since we specified the timeout to be 20 seconds. So in less than 20 seconds, we should connect to the target. And we did, so we can see we got a connection from our Windows PC at this port, or the connection is from this port. We can execute the commands, we can do anything as in the previous videos, so our actually persistent with the timeout of connecting actually works right now. So at this point, all you need to do is deliver this reverse shell to the actual target and you will be able to connect to them anytime you want, as long as their PC is on. So that will be about it for this tutorial. I hope you enjoyed it. And in the next video, what we will do is we will see how we can actually download some files from the internet with our reverse shell. Hope you enjoyed this tutorial and take care. Bye. Hello everybody and welcome back to this tutorial. And right now let us call the function in our reverse shell which will allow us to download to the target system any program we find online. So all we will need to specify is the path to that program in a certain website and our reverse shell will automatically download it in the target PC. So let us go to our reverse shell. Let me just delete once again everything unnecessary. And nano my reverse shell.py. And right here, in order to do that, what I need to import is the actual requests library. So import requests. What this library allows me to do is actually navigate through the actual website and get a certain URL and get its content so I can write it back to a file. So that is basically what we are going to do. We are going to get the URL, read its content, and write that content from that file into another file that we make on target PC. So we will call that function right here, and we will call it download. So simply as that. Now don't actually confuse this download right here with the download from here. This download is basically downloading the files from the target PC, and this download is actually downloading the files to target PC from the internet. So let us paste it right here, and this download function can take the URL as an actual input. So we will paste the URL to this function, and all we want to do is make something called get response from the certain URL, and in order to do that we need to code requests.get. This function right here will basically get this URL that we specified with the requests library. Then these contents we need to write to the file. In order to actually name a file the same as the file that we want to actually download, we can just type here file underscore name will be equal to the URL.split. We want to split it at the slash. Now I will explain this in case you don't understand. And we want to take the last part of the split. This -1 basically represents the last part. So let me show you what I mean. So for example, if you have google.com/release/downloads/python.exe. For example, this is the URL, and python.exe is the file that we want to download to the target PC. What this right here will do is it will split the URL everywhere there where it has slash, and it will take the last part from the URL, which will be just python.exe, which will be our file name. So let me just delete this. Our file name is specified. All we need to do is run our with open, and the name that we want to write to the file is basically stored in the file name variable. We want to write bytes, so VB, and we will call it the file descriptor as out_file. We can call it just like that. And what we want to do is out_file.write. And the thing that we want to write to this file is from the get response response, we want to get its content. This will be the content of the file that we are downloading. So this is basically the entire function. All we need to do is call it in our shell function once someone specifies a certain command. So in order to name that command, we can just call it get. So if you specify get and then there's an empty space and then the URL, it will download that file. So let's do it like this. We know that get has 3 letters, so else if command and then first 3 letters equal to get. Then we will try and accept the download function. So we will try to download the URL. So right here we need to specify the URL, and in order to specify any URL that the user of our server specifies, we need to type here command and from the 5th element till the end. Since our command will look something like this, so get google.com/release/blah blah blah, and then we need to get the URL from the 5th element, so it will just print the rest of this string. So let us go back here. We specify the download function right here, and what we want to do is send to our server reliable_send. We will send with a plus downloaded file from specified URL. So we will send this, and in case it doesn't work, we will just send, so reliable_send failed to download that file. So these are the 2 strings that we were sent whether the download function works or whether it doesn't work. And right now I believe this is all we need to code. In the server side of the code, we don't really need to code anything because we send the command to download the actual file from the URL, and then we wait for the reply. The reply will be stored in the result, and it will get printed either failed to download the file or download the file successfully. So nothing really here to code anymore. All we need to do is compile the actual program, root.wine, drive C, Python. We will see this 1,000 times in this section. So scripts by installer, no console, one file, reverse underscore shell.py. So let's let this compile, then we will transfer it to the actual Windows 10, so let me plug in my USB drive. Okay, USB drive plugged in, reverse shell compiled. We need to remove it or move it to the media root Kali Live. Let me just delete everything right now. And I will run my server right here in order to listen for the connection. Let's run the reverse shell as well. So run it like, okay, so fail to execute script reverse shell. Now this is a good error because I believe I know why it happened. So let me just show you what we can do. First of all, we will need to close this. This can happen because our reverse shell, if I nano it, you can see we right here have a requests library. Now, basically, our Pi installer, or pardon me, our Pi installer doesn't really know this library, so we probably need to actually download it to our Wine folder. Or let me just check if I name this library correct. Requests. Okay, so that is correct. In order to get the requests library for the Pi installer, we can type wine.root.wine. Then we need to specify drive C, Python 27, and then python.exe -m, and then pip install requests. You just press here enter, and right here it will collect the requests library, and then if we compile it once again, right now it should work. Hopefully this is the error, so we can actually fix it right here. Let's wait for the requests library to actually download for our Wine, and you can see it is downloading it. So that was the actual error, and this is a really good error to actually get, since right now you know how to download any library that you might not have for the Wine. So you can just download it with that command. Just at the end, all you need to specify is the name of the actual library. But right now what we need to do is actually compile it once again. So we compile it, we will plug in the USB drive in order to send it once again back. Okay, so USB drive is plugged in. This is compiling. Hopefully it shouldn't take too long. Here it is. Let us go to this directory and move reverse shell to the media root and Kali Live. Go one directory back, run our server. Okay, address is already in use. We will fix that just by actually restarting our terminal. So open once again terminal. Let me enlarge this in. And let me go to my Python reverse and then run my server. Right here, I will paste once again my reverse shell, run it. You can see right now we do not get any error, so everything works perfectly right now that we actually downloaded the requests library. And here, in a few seconds, since the 20-second timeout, we will be getting the connection from our Windows 10 machine. And then what we can do is actually test our get function. So in order to test it, first of all, we need a file to download from the website. We will use my Apache 2 web server. So in order to actually run the Apache 2, you can just type service Apache 2 start. Once it started the Apache 2, we go to the cd var www.html, and there you will need to download some of these files. So in my case, let us download the index.html. So let me just remove the other file so it doesn't confuse us. And we will try to download this index.html file. So if you go right here, 192.168.1.9, the index.html file is basically this HTML file containing the Facebook page. It is from our previous part in our course. So we'll try to actually download that file, which will contain the HTML code for the Facebook page. So let me close this. It is at place. We try to execute some command right here, and then we get http 2./192.168.1.9/index.html. Downloaded file from specified URL. So let us see if we go right here. we have the index.html file right here. If we open it, it should open the same page as the Facebook page saved on our Apache 2 web server running on Kali Linux. So let us see. It is opening, and here it is. Okay, our get function works really well. So that would be about it for this tutorial. Hope you enjoyed it, and we will continue coding in the next lecture. Bye! Hello everybody, and welcome back to our reverse shell coding. And in the previous video what we did is we coded a function that will be able to download a file from the internet to the target PC. Now let's see what else we can code for our reverse shell for it to have multiple functions that we can use once we actually infect the target with our payload. So let me just zoom this in, and we will navigate to our Python programs, reverse shell, and we will nano our reverse shell. Now let me just delete from the previous compilation these unnecessary files, so we can only have our two main files, which is the server and reverse shell, and let me nano my reverse shell. So we have the download function right here. We perform the connection every 20 seconds. Now let's see, for example, how we can take a screenshot from the target PC. For example, let's say they are using Facebook and sending messages, and we want to, for example, see what messages they are sending. Without implementing a keylogger yet, we can actually run a screenshot and see their entire screen, as many times as we actually want. So, in order to do that, we will need to import a library, which I'm not really sure if it comes with the PyInstaller. Maybe we will need to install it while compiling the program. So, the library is called MSS, and we will import it like this. So, from MSS, import MSS. Now, before I do this, let me just check out in Python, import MSS. Okay, so Python 2 doesn't have it. Let me just try to import it like this. So from MSS, import MSS. Okay, so we know that the library is not in Python 2, and we can install it with pip install MSS. Now if this doesn't work, we will just install it for the actual PyInstaller in the wine folder, since that is actually where we need it, but you can also install it for your own Python in Kali Linux if you want to. We will not really be running this on the Kali Linux target, we will be running it on the Windows machine, as usual. So we can see it's successfully installed, and now if we go to the Python and import MSS, it is there now. So you also have it in Kali Linux Python. So we imported it. Now let's make a function right here, for example, and we will call it screenshot. Let's leave it for now on. Right here, we will code it in just a second. What we want to do is add an actual option right here. So we want to create another else if statement for the actual screenshot. So let us add it right after the get command. We can just go down here, make else if, and then the usual command. And then let's count the letters. So screenshot actually has 10 letters. So we want to make sure that we specify everything until the 10th character equals to the screenshot. This is the function that we will use in order to screenshot target PC. So we will just type in the server command line screenshot, and then we will get back the screenshot from their PC. And what we will try, since this doesn't work every time, for example, I tried getting this to work on Windows XP and it just doesn't work. I believe it works on Windows 10 and Windows 7. On Windows 10 it works for sure, on Windows 7 I'm not so sure, we will have to try it out later. So we need to run it in a try and except rule in order for our program not to crash, for example, once we encounter a target that cannot take screenshot. So what we will try is we will try our screenshot function that we will code in just a second. Once we do the screenshot function, we need to send that screenshot to our Kali Linux machine. So basically, since we are on the reverse shell code right now, what we will do is we will actually open that file for reading bytes, and we will send the actual data to our server. So now before we do any of that, the actual screenshot, once you use the MSS library, will save the screenshot under the name like this. So monitor -1 .png. So this is the name how this MSS library will save the screenshot under, and every screenshot will be actually saved under this name. So that can present a problem to us, because if we make one screenshot and it saves under this name, and we want to, for example, take a second screenshot, and we take it, it will rewrite this screenshot right here, because it will have the same name. So we will no longer have the first screenshot. So we need to actually make sure that doesn't happen. So how we will do that is we will actually fix that in the server-side code. For now on, all we want to do is open the file under this name, since after we perform this function, there will be a screenshot on target PC. We want to open it, read data, and send data to the server. And in the server, we will rename this so it doesn't actually rewrite other screenshots that we take. So first of all, with open and close brackets, between the double quotes, let's specify monitor -1. Now make sure to specify exactly the same name, otherwise this will not work. So PNG, and then comma, and we want to read bytes from that screenshot. Since we are getting a picture, whoops, we don't need another bracket. We want to open it, let's say, as CS, so shortly for the screenshot. And what we want to do is reliable send, reliable_send, base64, base64 dot b64 encode. Since we are the one that are actually sending this, we want to encode, and the thing that we want to encode is the sc, or our screenshot dot read. So let me just count the brackets. We have 1 open, 2 open, 3 open, and 3 closed. So everything is good right here. And also, for example, let's say that the reversal is running on the desktop. So the target found it on the desktop, double-clicked it, opened it, and we took a screenshot. The monitor-1.png file will be saved on the desktop, which can actually trigger some users. They basically find the screenshot of their own PC, so they maybe believe something is wrong by then. So what we want to do is actually delete the screenshot as soon as we send it. Now you will notice that you will not even be able to see the screenshot for a fragment of a second, so nothing will be suspicious. If after the actual opening of the file and sending, what we want to do is use the OS library, and we want to .remove, which will remove a file that we specified between the brackets. So let us just copy the name of this file, which is monitor-1.png, paste it between these brackets, and this will remove the actual screenshot right after we send it. And in the except rule, what we want to do is reliable send _send, and let's send a string, basically a string that will say failed to take screenshot. Now why we are sending the string? Well, basically, if we fail to take the screenshot, we will have a file, or not a file, we will get prompted this string right here, failed to take screenshot, and then we will know that the screenshot function doesn't really work on that target. So now that we did this, what we need to do is actually code the actual screenshot function, which is rather short. It is just 2 lines, so don't worry, nothing really too much. Our MSS library already did the entire job for us. All we need to do is type with MSS, and that as a function as screenshot. So this is the name. You can specify anything you want, it doesn't really matter. We want to use screenshot.shot, and this will save the screenshot for us. This is the entire screenshot function. So basically, if I'm not mistaken, this should be entire actual code for the screenshot. Now let us save this. So Ctrl-O save, Ctrl-X to exit, and let us nano our server and see what we need to do once we actually get the screenshot back. So let's first think about it, or let me just at the beginning create the actual else if statement. So else if, we need to perform the same thing, command, first 10 characters, equal to screenshot. Let's think about it, what we actually need to do right here. As I said, it will save every screenshot as the same file, so we need to change that. We will use a counter, for example, or not a counter, we will just increase the variables. For example, let me show you right here, so maybe you will understand it better. If you go down here, and for example, at the beginning, you create a variable count equals 1. So count equals 1, and that is a global variable, so we can use it in this function right here. The reason why we are using the global variable is because we need to actually increase that count variable every time we run this screenshot function in the while true loop in the shell function. So let me just show you. We will actually receive the data first of all, but before receiving it, we need to open the file under a specified name that we want. So what we will do, in order for that file not to rewrite, since every screenshot has the same name, we will name it screenshot %d, and then we need to use the %count to be replaced instead of this %d. So since count is 1 at the first screenshot, it will be the name of screenshot 1. Then we will increase it at the end and it will be screenshot 2 and so on and so on. So since we are the server, we need to open for the writing bytes, and the name, we can name it fin. Doesn't even matter. You can name it anything you want. Or maybe if it is actually confusing for you, let's name it just screen, so you know it is a screenshot file. And actually we need to receive that file right now. So let's do it like this. We will create an image variable, and that image variable will store the data from the received screenshot, so reliable receive. And since we encoded it with base64 encoding, we need to decode it, so we will create image underscore decode or decoded equals base64 dot b64 decode. And the thing that we are actually decoding is the image itself. So just type here image. And now what we want to do, since the try rule in our reverse shell actually saves the image or sends the data for the image, what we want to do is, if we successfully took a screenshot, we want to save that to a file. If we didn't take successfully screenshot, that means that we are getting the string back, which will say failed to take screenshot. In that case, we want to print it to our screen. So in order to check that, we can just check first 4 characters, for example. So if image underscore decoded, and then first 4 characters equal to this string, which is the string that we specified at the beginning of the failed to take screenshot function, then we want to print image underscore decoded, because that means that the actual image failed to take. So image underscore decoded. And in any other case, we want to actually write it to a file, because that means that we successfully took the screenshot. So we'll just use screen.write. And we want to write image underscore decoded. And make sure that you increase the count variable right after you do this. But not right here, since that it will increase it even after you don't take the screenshot. You want to increase it right here, so count plus equals 1, which will just increase the count variable by 1. So that is the entire actual program. Let us now save this. We can compile our reverse shell. So wine root drive c python scripts installer -- no console -- what is the next thing? Okay, one file, and then reverse shell.py. Let us run this with enter. This will compile, and then we will run it on the actual Windows 10 PC. And later on, when we'll actually code the threaded server, which will accept multiple connections, we will try to run a screenshot on Windows 10 and on Windows XP. So let's wait for this to compile. Now, if my IP address changed, we will need to compile it once again, since I just started Kali Linux. Didn't really check the IP address. Hopefully it didn't. Okay, so let us check the IP address, .1.9, and let me check the IP address that is specified in the actual Kali Linux machine. Pardon me, in the program. Okay, so it is .1.9. Good. So right now, let us plug in my USB drive. Or let me actually show you another way that you can download this reverse shell.exe without plugging in your USB drive. You can just go to the Google Chrome. If you, for example, for some reason don't have USB drive, then you can just go cd dist, and you can move this to the move the reverse shell to the var/www/html, which is the standard Apache 2 folder. So you just move it right there. You can see it's no longer here. We can delete the rest of the files. And all you need to do right now is actually run the Apache 2. So you can do that with service Apache 2, oops, start. And this will start the Apache 2 for you. All you need to do right now in order to access that file is you need to know the IP address of your Kali Linux machine, which we already really know. It is 192.168.1.9. So we can just go right here, just type 192, oops, 192.168.1. Oops, we have two dots, so .168.1.9. Okay, so we still have the Facebook login page from the previous tutorials. Let us just remove the actual Facebook login page so we can see the file. If we remove index.html, we only have our reverse shell.exe. If we refresh, here is our reverse shell.exe. So all you need to do is just click this in order for this to download. You can see it downloaded successfully, but you will notice one thing. Let me just show you. Once it is on our desktop and we downloaded it from the actual Apache 2, it will no longer run as the USB transfer station. As you can see, this is something that we didn't really encounter before. Right now it says Windows protected your PC, prevented an anachronized app from start. Running this app might put your PC at risk. All you need to do is go to the more info and run anyway. So now our reverse shell is ran, and for some reason we get fatal error. Okay, I think I know what the reason is. The reason is because we actually only installed the MSS library for the actual Python in Kali Linux. We forgot to install it for the Python in Wine, which for some reason I said we need to do that and then I forgot to do it. But let me just do that real quick. In order to install it for the Wine, run this command right here. So wine/root/.wine/drive/c/ Python 27, I believe, and then python.exe. Then you need to specify -m and then pip install and then MSS. Run this command, and this command will basically just download the MSS library for the Wine, and then hopefully everything will work as usual. So until then, I will just plug in my USB drive, because I find it easier to actually transport via the USB. Okay, so we can see here it is. Now we have the MSS library. Now we can actually, let me just find where the reverse shell is. Okay, so here it is. Let us navigate to the previous command. Here it is. I will compile this real fast so we don't waste time. Everything has finished. Go to the dist, move the reverse shell to your Windows 10. So root media, or it is media root. Or basically I just need to plug in the actual USB drive before I try any of that. So /media root Kali Live. We move the reverse shell. Hopefully that was the error. I really can't think of anything else being the error. So remove this, remove build, remove reverse.spec. Let us unplug my USB drive. And I can run my server for the listener, even though we can actually run the reverse shell first, as we saw that we actually created a function to connect every 20 seconds. And right now, if we run, first of all, you will notice we don't get that error prompted, we don't get that warning prompted that says this app might put your PC as a target or something like that. I'm not really sure what it even said, but it doesn't even matter. Right now it doesn't say it because we didn't download it from the internet. And here we get the connection back. So all we need to do is first lower this so you can actually recognize the screenshot once I take it. And if I just type screenshot, oops, local variable count referenced before assignment. Okay. What do you mean? So nanoserver.py. Yeah, actually, let me just double check everything right here. We need to actually code this at the beginning, because it goes through all these functions and then it runs to a count variable which it doesn't really recognize. So let us code it. Just move the count equals 1 at the beginning, even though we didn't really run that function yet, but it doesn't even matter. Let us just try once again. We listen for the incoming connections. It should come any second. As you remember, we have a timeout of 20 seconds before connecting. And as soon as it does, we will just, first of all, check a simple command to see if our program works, and then we will run the screenshot and see how it looks like. So here it is. Let us just run who am I just for a simple check. Then I can lower this so you can see the screenshot better. And if I just type screenshot, what do you mean count referenced before assignment? Oh, I think I know what does it mean. Sorry about that. It doesn't really know what count variable we are using. We need to specify right here at the beginning that we are referring to the global count variable. I believe that is the problem. Sorry about that once again. And hopefully third time, third luck, so we will be able to run this right now. Even though we crashed already 3 or 2 times, something like that. But hopefully everything will be good to go right now. The problem was, I believe, because that global count string, or pardon me, global count command wasn't really implied in the actual shell function. So let us just run it straight away. Screenshot, we can see it finishes relatively fast. Now let me just lower my screen right here so you can see. Screenshot, if I run it, you can see there really isn't anything on the screen that appears, such as the monitor1.png, since this performs really fast and it sends the data, and as soon as it does it, it will remove the screenshot. And if you want to check actually where the screenshots are, we can first of all press Q to quit the program, and you can just type ls and you will see in this folder there is screenshot 1 and screenshot 2. Let us navigate to that folder. It is in the root, Python programs, and then reverse shell. Oops, we need to go to the places, I believe. Then go to the computer. Then find the root right here. You just find it. Here it is. Go to the Python programs. Go to the, where is it? Reverse shell. And screenshot 1 is basically just the screenshot of our full screen Kali Linux, as you can see. You know it's a screenshot of Windows 10 PC because we can see our Windows 10 icons down here. And the second one is more convincing since we can see even the Windows 10 background in the actual screenshot. So our screenshot actually works perfectly. It is even a good resolution, so everything is good to go. You can see everything in the actual picture and you can perform as much screenshots as you really like. All I need to do afterwards is just delete these screenshots if you want to. So remove screenshot 1, remove screenshot 2. And you will be good to go for running the next program. So that will be about it for this tutorial. What we will do in the next one is we will code a simple help function that will print the help to anyone using our program. So we will just implement all of these things that we coded in a help function, and later on we will continue implementing more things to our actual reverse shell. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody and welcome back to this tutorial. And before we actually implement our help function, what I want to do is show you a simple function that will check whether your target is running your reverse shell as an administrator or as user privileges. That way you can know what your limitations are and what you can do with the target PC. So let us nano our reverse shell.py, and right here what we will do is, for example, right here we will code a simple function called is_admin, which will check the admin for the admin privileges. What we need to do is use a global variable admin. Now the reason why we need to use a global variable admin is because we will actually use it in the shell function as well. Now there is another way, and you can just return the variable admin from this function to the shell function, but it doesn't really matter. Whatever you prefer, you can continue with that. I will use the global variable admin. In order for us to do this, what we need to do is try and accept as usual. So we want to try and accept. What we want to try is actually accessing a certain directory in Windows or the temp directory. Now the reason why we are trying to access that directory is because that directory can only be accessed once you're an administrator. So what we will do is we will try to access it, and then if we actually can't access it, we will know that we are not the admin. If we can access it, we are running this reverse shell as the administrator, and we know what our limitations are. So in order to do that, we will just put it in the temp library, variable equals os.listdir. What we will do right here is we will try to list directory as it says right here, and we will use an OS library to perform that, so os.sep.join. And what we want to do right here is use an actual thing that we already used before, which is the os.environ, which we used in the app data. So right here, we want to get a certain environment, and that environment will be the temp directory. So let's open this. Now make sure to open it like this. So in these inner brackets, what you need to type is between single quotes, you want to type system and then root, then comma, and then another single quotes, C, we want to access C, 2 dots, backslash, and then we want to use Windows. So basically, then you close the first bracket, and then you type comma between the first and the second bracket, and there in the single quotes you type temp. Or we need the actual square brackets right here, and not the, let me see in our app data what type of brackets we use. So we use the actual square brackets, not really sure right here. Probably we need to use them here as well, or we need to use them right here, I believe. So if we just type square brackets right here, open it there, close it right here after the temp, and then close these two brackets, which are the other two brackets from here. So this one and this one are rather confusing command, but it doesn't really matter. And then if that works, or if that doesn't work, we want to type admin variable, which is our global variable, 2 exclamation marks for the error, and we want to type user privileges, exclamation mark. In any other case, or basically in case where it did work, we want to type, or not exclamation mark, we want to add a plus as it did work. Let me adjust the space between the double quotes and the actual equal sign, and we want to type administrator privileges, exclamation mark. So this is our entire function. All we are left to do actually is just basically code the isAdmin in our else if statements. We will code it as a check function, so we want to actually add it, for example, right here. We can say else if command, and then first 5 letters equal to check. So once the user of our server just types check, it will check for the administrator privileges. And how we can do that? We can just try to run the actual is_admin, and then we will reliably send the admin variable. Since it is a global variable, we can access it from here, and we want to send the global variable. In the accept, all we need to do is just reliable send, _send, and between the brackets we can just type here can't perform the check, since something went wrong and we really can't take any action in order to see whether we are administrator or whether we are a user. So that would be about it. Let me just compile the actual shell right here. Let's compile it real fast. Let us, while it is compiling, move it right here. A rather small and short tutorial. This is really fast function. We just want to have that just so we can know. Well, basically it's not really that much of a useful function, such as the other ones that we coded, but there's really no point in not having it there. Of course, you can add as many functions as you want, as many available options as you want to this reverse shell. We will not be adding any more except the actual keylogger and the threaded server, which is really important, so make sure to stick for that. So let me just move this to root, Kali live. But as I was saying, you can add multiple functions. Just search on the internet, for example, any type of function you want to input right here, and then make sure to code it properly into the actual server and the reverse shell code. So remove this, remove build, remove. Okay. Let us paste this to the actual desktop right here. And what we can do is run our server and run the reverse shell. So it seems that it worked properly. Let us go to our actual Kali Linux and we will perform the check right away and we will see whether it works or whether it doesn't. So just type check. You can see we are user privileges. So we know that we are now user privileges, but if we, for example, quit this and run this server once again, or we can actually run this first and right click, run as administrator. We want to run it as administrator. Our reverse shell is now running and we run the server once again. I will leave this so you can see the difference. So first time we got the user privileges, and right now if we run the check once again, we will see what we will get. Hopefully we get administrator privileges, otherwise this doesn't really work. So check, and we can see right now we are administrator privileges. So this function works really well. Rather short tutorial, and we will continue in the next tutorial with making our help options and then proceeding to the keylogger coding. So hope you enjoyed this tutorial and I hope I see you in the next one. Bye! Hello everybody and welcome back to this tutorial, and this is the last part of actually our reverse shell, or basically of focusing mainly on our reverse shell. And right here we will code our help options to prompt the user, and what we will do after that is we will try to implement a keylogger to our reverse shell, so not a specific keylogger that will be a standalone program. It will be rather implemented in our backdoor, and then we will with two different actual commands run the keylogger and stop the keylogger. And then afterwards, once we do all of that, what we will do is we will actually try to create another server. We will not be coding anything in the reverse shell anymore, but we will try to create another server which will be able to accept multiple connections at once. And then we can navigate between the sessions and choose which target we want to actually compromise at that moment, which is basically a command and control center. You can then use it further on to perform DDoS attacks, or something like that. Is most likely used for that, since you gather multiple PCs connected, then you send the same command to all of them and then they start doing what you want them to do. But more about that later. Right now what we want to do is go to the reverse shell, and all we can do right here is code a simple string which we will send to our actual server. We can code it right after the Q option. So then we will have else if command equals to help. What we can do is basically just make a variable called help underscore options, and that variable will be equal to a string containing all of the current options that we have. So we will use triple single quotes in order to be able to actually create a multi-line string. So I will show you how this works. What you need to do is, first of all, let me just check it right here. 1, 2, 3, 4, 5. And also here I need to tab it 5 times. 1, 2, 3, 4, 5. So it can actually be in the same line. And first thing we want to type is download path. Now this download is the function, and then path is the path that we want to download from the target PC. Okay, so, and we can do it like this. Download a file from target PC. All we need to do is right here, use the same for the upload. So upload and then the path. And then we can use 2 dashes and then arrow. Upload a file to target PC. The next thing is the get URL. which is our download function for downloading the file from the internet. And then what we want to do, download a file to target PC from any website. From any. Now, of course, you don't need to actually name all of this as I do. You can just name it whatever you find easy and start path. Or actually, did we code the start? Let me just check right here. If we didn't, we will code it really fast. Okay, so it seems that we didn't. And what start does is basically it will start the program without us waiting on a single program to close before continuing. Now, what I mean by that is, for example, I will just explain it in theory right now, so we didn't actually compile and run it just to show you. But basically, just imagine that we ran the reverse shell, and then as a command, we send to the target start notepad. Now, if you can see, if I open my command prompt and actually run that command, start notepad, it will start a notepad. But if we did that from our reverse shell, it still would start a notepad, but also it would actually block on that notepad, and it will not allow us to execute more commands until that notepad is closed. So we would need to wait for a target to actually close the notepad, and then we will be able to actually continue executing commands. Same for the example calculator, so start calc, it will start the calculator, but then still we wouldn't be able to execute further commands until the target actually closes the calculator. What we want to do is actually be able to open programs, and as soon as they open, we can actually execute more commands right after they open without the target needing to close them in order for us to continue. So we will use a subprocess library to do that. Don't worry, it is a rather short function. We will just code it right here, right beneath the screenshot function. So else if command, and then first 5 letters equal to actually starting the program. So start. What we need to do is try to open the program. So make sure to always use try and except, because anytime, for example, the user of our server can specify the name of the program wrong, basically they just mistype the notepad name, and then our program will crash because you don't have the try and except rule. So make sure to always have it, and we will use subprocess.popen for opening the actual process, and we want to open the process named from the 6th letter, from the 6th character till the end. Of course, the 6th because start has 5, and then the empty space 6th, and then goes the name of the program. And also we need to make sure to specify shell equals true. And then we can send to our target, so the server actually receives something, we can send reliable underscore send, and we can send started. Simple as that. And all we need to do is in the except rule just send fail to start. And that is the entire actual start function. So plus, or not plus, we need 2 exclamation marks, or you can use a minus, whatever you feel like it. And then failed to start. Okay, so that part is coded. So right now we can add it to our actual help settings. So dash start a program on target PC. The next thing we want to do is screenshot. So screenshot, take a screenshot of target's monitor. The next thing is the check. So check for the administrator privileges. Did I code that correctly? Hopefully that is how you pronounce privileges. Doesn't even matter anyway. And the last thing we want to add is the Q command. So Q is equal to closing the connection or exit the reverse shell. And all we need to do, since we opened the triple quotes at the beginning, we need to close them right here in order to make this a string. As you can see now, it is a multi-line string. And then all we need to do is send the actual string to the server. So reliable underscore send help options. Okay, so if I'm not mistaken, this should be it. And right now, if I save this and we compile our reverse shell with the same command as usual, and we go right here, plug our USB drive. Let's wait for this to compile, and then we will first check the start function that we just coded to start, for example, Notepad, Calculator, Explorer, and so on and so on. And then we will actually get the help options, or we can just do in reverse, doesn't even matter. Let's move our reverse shell to the USB drive, media, root, Kali live. Okay, we can unplug the USB drive now. Open it, paste the reverse shell.exe, run the reverse shell.exe. We don't get any error, that is good. Now, until that is running, we can just delete all these files. So remove this, remove build, remove reverse.spec, and let's run our server right now. So first of all, let us try for the help command, so we can get the help options printed back. We got everything. Let's type who am I, works, and then help, and here are our help options. Let's try to run some program, for example Notepad. If I just type start Notepad, it says started, Notepad is still open, and we can still execute commands further on. But let me just show you what I was talking about. If I just close this Notepad and instead of start Notepad, type Notepad, it will still open the Notepad, as you can see right here. But right now, I need to wait for that Notepad to actually close, as you can see, to be able to get the shell back and execute more commands, as you can see. Instead, I can just type start calc for starting the calculator. It will print started and it will open the calculator, and then I can start Notepad as well, and so on without closing the previous programs. And let's press Q in order to quit the reverse shell, and everything works properly. So, hope you enjoyed this tutorial. What I will show you in the next video is how you can compile this program in order to make it more believable, and in order to make your target actually open it. We will see how we can create an image out of this program. It doesn't have to be an image. We can create something as a PDF file or something like that. So, hope you enjoyed this tutorial, and I hope I see you in the next one. Bye. Hello everybody, and welcome back to our reverse shell section. And in this tutorial, which is basically our last tutorial, we will see how we can compile our reverse shell in order to make it more actually convincible to the target. So for now on, we saw the usual compilation command, which is, let me just find it, which is this command. As we can see, we use divine, the point installer. We set the settings to be no console. We set another setting to be one file, and then the name of our actual file. Right now, what we can do is we can actually create any icon we want for our actual reverse shell. As you remember, the previous reverse shells actually had the icon, let me just show you, the icon similar to this, which is a standard PyInstaller or Python exe icon, which really doesn't seem convincible, and if target sees this, they will not open it. But you can add some regular icons to our reverse shell, and it will make the target actually click it. We can also make our reverse shell to be an audio file. We can make it to be an image. We can make it to be a PDF file. Basically, the process is the same. I will show you how you can make an image, and I will show you how you can make a simple icon. So first of all, let us start with the actual icon. You can just go to the, let me just move this in since we will not run any command. You can just go to your Firefox and simply just search some icons on the actual Firefox or some websites that actually have icons. Then you can download that icon file, and then you can use it in the compilation of your reverse shell. So you just go right here, type icons, for example, doesn't even matter. Hopefully something will come out. I remember using one website which had a bunch of different icons, but I'm not really sure how it was called. Hopefully we will find something like that. Okay, I believe it was Icon Finder. So let's go with that one. You click on the icon finder right here. Not really sure why is it this slow. Okay, so here it is. Search for icons, and then you can just type here, for example, Google Chrome icon. For example, it doesn't have to be, you can just type PDF, Facebook. As I said right there, you can just type any icon you want. And here you have a bunch of different Google Chrome icons. You can use the regular Google Chrome. Oops, where did it go? Okay, so here it is. You can use regular Google Chrome icon. You can take any of these icons you want. For example, let's take this one. Or this one. Let me just go right here. We can download the actual icon. I believe it is in the download the second PNG format. Okay, so let's download it in the PNG format. And then what we will need to do is we will need to actually convert it to the ICO file. So first of all, let's see if it will even download. I hope this is a free one. Yeah, it is. Open in icon editor, free icon downloading it. Okay, so open file. We don't want to open it, we just want to save the file. Okay, we have it right here. It is in our downloads folder. You can see my Firefox is currently a little bit slow, but here it is. Icon finder, Chrome. And let's actually try to make an icon from that image. Since we got the .png file, now we can use the PNG to icon. Just simply search that. Icon convert, create icons from PNG and JPEG images online. So let's see how this will work. I am for the first time using this website, so let's browse for our file. We go to the downloads, and in the downloads we open our file. So, and then we upload it. It will say successfully uploaded it. And let's see what we need to do. Crop your image. We don't want to crop anything. Convert to ICO. ICO for Windows 7, Windows 8, Vista and XP. Doesn't seem to have Windows 10, but hopefully it will work. Download your icons. Here it is some ICO file. Okay, save it. And it should be in the same folder as our PNG file. Or our PNG Chrome image. So let's open our downloads folder. Why aren't you opening it? Let's just navigate it through our terminal since our Kali Linux is a little bit slow. Here it is right here. Let us rename it. So move icon finder underscore ICO to black chrome.ico, since it will be much simpler to actually use it. And now let's see if we can actually compile with this. So we can go to our root or not, yeah, root Python down programs, reverse shell, and let's navigate or not navigate, let's compile our program and make it have an actual icon. So we use the same thing as before, wine, drive C, then scripts, I believe, or no, Python 27, then scripts, then pyinstaller.exe. Next thing we want to do is use one file, no console, and then in the order to add the icon, we have to specify --icon, and then the path to the actual icon, which is root, downloads, and then blackchrome.ico, and then the name of our file. So let's press here enter to see whether this will work or not. So this is compiling. Then we will plug in our USB drive. In order to move our reverse shell to the USB drive. So let's wait for this to finish. And then after actually seeing if this will work, we will add an icon of our actual image that I have on my USB drive, and we will see how our program or our reverse shell can have an icon of an image and also open an image. So let me just check this out right here. Change directory to this, move reverse shell to media root Kali live. Unplug my USB drive. Let's check it out. Okay, so it doesn't seem to have the actual icon. Well, that seems a little bit strange, but it doesn't even matter. I use some website that I haven't used before. Let me just check something out. Sometimes you need to refresh multiple times in order for it to show for some reason. But no, this one just doesn't have it. Okay, let us try another one. And that another one can just be our picture, since I actually took in matter that this might happen. So I used some picture that I already tested before, which is the actual, let me just change my directory to my Kali Live, which is this dragon wallpaper Chinese.jpg. If I copy it, so copy to my root Python programs reverse shell. And then I can change my directory to there. Python programs reverse shell. And now, at the same time, let's make our reverse shell open this as well as have the icon of this image. So in order to do that, we need to navigate our reverse shell.py, but let me delete this other stuff for now. And let me nano reverse shell.py, and we need to import a certain library. If we don't have it imported yet, let me just check everything right here. We need to go down to our program, and right here where we actually create the persistence, right after it we want to open the actual image. Now in order to do that, we will use a PyInstaller folder or temporary folder, which we can access with the sys._me ipass, or let me just show you. If we create an actual location, which will be underscore file name, which will be the location where our PyInstaller will store the actual image which we compiled during the compilation, which in our case will be the dragon wallpaper Chinese. I believe that is the actual name. So we need to specify the location to be sys._me ipass and then plus, and between the double quotes we need the backslash and then the name of the actual image. So let me just save this, type ls, copy the name of the image, just so we don't mistype anything. So make sure to copy the exact same name of any JPEG image you want, and then specify it right here. So use your JPEG image, paste it right here. We can see right now we have the full path, and all I want to do right now is try to open this path with the subprocess, subprocess.popen, and we want to use the subprocess library so we can continue executing our code even after the image is opened. We want to open the program, or in our case image, at the location of file name, shell equals true as usual, and in any other case we can just perform any type of code, doesn't even matter. We can just perform some simple addition. So number equals 1, number 2 equals 2, number 3 equals number plus number 2. Now you might be asking, why am I doing this? Well, basically, first of all, we don't really have anything to do in the except rule, and second of all, we want to perform some simple functions that really do not do anything for our code, because sometimes these functions can help bypass the antivirus. Since sometimes antivirus can check out your program and see that you have some regular functions, such as in our case this simple addition function, and then they think this is a legit program. Now that is another case, but for now on we just don't need to bother coding anything else. If this doesn't work, we will just proceed to actually opening the shell. Now also make sure that I'm running this in the actual if not os.path.exists. Now that is the reason behind that is, for example, if we are not running this on the target for the first time, we don't want to actually open an image. So if we run it for the first time, let's say target downloads an image, which is an actual reverse shell from us. They put it right here. Let me just delete this for now. They place it right here, they run it, the image opens up, and then we create the persistence, which will open the backdoor at every boot up of the actual computer. Now imagine if at every boot up the same image opened every time. It would create a suspicion they would know something is wrong, and then they would investigate further on. So we only want to open the image for the first time of the target running the program, and any other time we don't want to open anything. That's why this part of code is tabbed in this section right here. So right now, if everything is performed correctly, we can save this, and all we are left to do is perform the conversion of JPEG to ICO. So we can just use a simple website, JPEG to ICO. We can go to the icon converter, or no, this was the one that we actually used, so we can go to the second one, which is convert ICO, JPEG to ICO. Let's click right there. It will probably ask us to actually upload the file itself. Okay, so here it is. Now let's click, let me just find, okay, so click right here. Now let's navigate to our actual Python programs, reverse shell, and our Dragon wallpaper Chinese. So open this. And you can see right here at the right side, it asks us to download the actual ICO file for this image. Just click on this arrow right here. It will ask you to save the file. Click Save File. It will download it. It will download it in the Downloads folder of your Kali Linux machine. Let us just double check that, just in case. Just as usual, our actual Firefox is a little bit slow. Okay. Doesn't even matter, let us just close this. We downloaded everything successfully. We don't really need this to be open anymore. Let us just check if it is really in the root and downloads folder. If we just type ls, this black chrome.ico we don't really need anymore. We also don't need icon finder, chrome.png. And we have our Dragon wallpaper Chinese.ico. So all we want to do right now is go back to our root Python programs, reverse shell, and perform the full compilation in order to get this icon to be the icon of our reverse shell, and also for the image to actually open once we start the program. So the full command will be something like this: whine, then root.whine, and then drive C Python 27 scripts PyInstaller. And first thing we want to do is use an option called add and then or --add -data, and between the double quotes we need to specify the path to the image we want to open, not to the ICO file but to the JPEG file. Okay, so we need to specify root Python programs reverse shell Dragon wallpaper Chinese.jpg. Now also make sure that at the end, before closing the double quotes, at the end of the actual path, add the dot and the comma, and then add the comma, and then add the dot at the end. So this specifies that we only use this file right here. So once again, --add -data, open double quotes, path specified, then dot comma, and then dot, and then close double quotes. And then afterwards we can specify --one file, --no console, --icon, and then the path to the actual icon, which is in our downloads folder. So the path is root, downloads, and then the actual name is Dragon wallpaper Chinese.ico. And all we are left to do afterwards is actually specify the name of the file that we are compiling. Press here enter. And while this is compiling, make sure that you go to your command prompt and to your registry, and if you ran the program before and didn't delete the registry, oops, let me just go right here, and didn't delete the registry and didn't delete the actual backdoor from the app data, make sure to delete it, otherwise this will not actually open an image. So right here, you can see I don't have anything. If I go to the app data, to the roaming, dir right here, just delete. I have, you just type, or let me just enlarge this, type dir once again. Windows 32 exe needs to go, or not dir, I need to del Windows 32.exe. And if I just type there once again, it is no longer there. It is also no longer in the actual registry. So that means that we are going to run our program for the first time according to the actual computer. And then, okay, so it is already plugged in. Move reverse shell to the /media/root and then carry live. We move our program, and right now we will close the actual USB drive, and then we will run it right here. And let's see what opens right here. For some reason, once again, we don't have an actual icon. But never mind, let's see if it will open the actual image once started. So we double click this. And we can see that it is actually opening image. It takes a little while to load up, but eventually it will load up. Okay, so here it is. This is the image that we actually coded in our program. And also, after opening this image, it even started our reverse shell. So now, if our icon actually worked, for some reason it doesn't want to show. But for example, if you restarted your PC, then the icon would be right here. Sometimes it just doesn't want to work, and sometimes it does. Basically, the command is always the same. So the command is this one. Let me just show it right here. You will always use this command. So whether it works now or not, it doesn't even matter. What matters is if we run our server, let me go on directory back and run our server, listening for the incoming connections, we should receive the connection from this reverseshell.exe. Here it is. You can run usual things such as who am I, then help to check our available options, and everything is good as usual. Now, we managed to actually open an image. That image could have also been a PDF file. It could have been an audio file, for example, some song or something like that. It could have been a PNG image. Now, some images don't really work, but most of them really do. I remember encountering some that didn't even want to compile for some reason. But the actual icon didn't seem to load this time, even though I think it is just a glitch in my desktop because I used the same thing I used before. And for some reason it doesn't want to show it right here, but if you try it a few different times, you will be good to go. Maybe try it with some different image, and maybe it will go even faster. So that will be about it for this tutorial. I hope you enjoyed it, and I hope that in the next tutorial you will stick with me, where we will actually code our keylogger for the backdoor. So that will be about it for this section. Hope I see you in the next one, and take care. Bye.